Tonight, there is no urgency, no destination waiting beyond the next few minutes, no puzzle that must be solved before morning. Only the quiet movement of the world outside, and one of the oldest stories continuously unfolding above the earth. The story of rain. As darkness settles across distant oceans, across empty deserts, across forests that have stood for centuries and cities that glow softly beneath clouds, countless droplets are already beginning journeys so small that they seem insignificant, and yet so vast in their collective influence that entire civilizations have depended upon them. Rain is ordinary. It is familiar. It taps against windows. It gathers in gutters. It darkens stone pathways and fills forgotten puddles beside roads that lead into the distance. And because it is familiar, it often becomes invisible to our attention. Yet hidden inside every gentle rainfall is an intricate ballet of physics, chemistry, temperature, sunlight, gravity, and time. Tonight, we will move slowly through that hidden world. There is no need to remember every detail. There will be no test waiting at the end. The facts may drift through your thoughts like clouds crossing a moonlit sky. Some may remain. Others may quietly disappear. Both outcomes are perfectly acceptable. For now, simply listen. Somewhere beyond the walls around you, moisture is moving through the atmosphere. Perhaps rain is already falling. Perhaps it is gathering far away over an ocean horizon. Or perhaps droplets that will someday become rain are resting silently inside a river, a lake, a leaf, or a patch of soil beneath the night sky. The journey has already begun. Water, at its simplest, is a molecule composed of 2 hydrogen atoms and 1 oxygen atom. A remarkably small arrangement. And yet water shapes continents. It carves valleys. It transports nutrients. It sustains ecosystems. It circulates endlessly between ocean and atmosphere in a planetary rhythm that has continued for billions of years. The physics of rain begins not in the clouds, but in sunlight. Every day, energy arrives from the sun and spreads across the Earth's surface. Some of that energy warms oceans. Some warms forests. Some warms fields, mountains, rivers, and cities. And some of that energy quietly lifts water into the air. This process is called evaporation. Individual water molecules gain enough energy to escape the surface and enter the atmosphere as vapor. They become invisible travelers. The ocean appears unchanged. The lake still reflects the sky. The river continues flowing. Yet countless molecules are departing every second. The atmosphere is never still. Even on nights that seem silent, air is moving. It rises and sinks. It drifts across oceans. It circles mountain ranges. It carries heat from one region to another. And within those vast, invisible currents, water vapor journeys upward. Far above the surface, temperatures become colder. The higher the air rises, the less warmth it can usually hold. Eventually, vapor begins to slow. Its journey changes. Tiny particles suspended in the atmosphere provide gathering places. Microscopic fragments of dust. Salt carried upward from ocean spray. Pollen drifting from distant landscapes. Around these particles, water molecules begin to collect. one by one, then hundreds, then thousands. A cloud is born. Clouds often seem substantial. They stretch across horizons. They cast shadows over valleys. They tower above coastlines like floating mountains. Yet a cloud is mostly empty space, a delicate suspension of tiny droplets, each almost unimaginably small. Together, they create shapes that have inspired stories, forecasts, paintings, and quiet moments of observation for generations. Long before modern science, people looked upward and wondered about clouds. They watched them gather before storms. They watched them dissolve in sunlight. They watched them drift over landscapes that changed far more slowly than the sky above. Even now, despite satellites and weather models and sophisticated instruments, there remains something mysterious about clouds. Not because we do not understand them, but because understanding does not remove wonder. Knowledge often deepens it. Far out at sea, beneath a layer of moonlit clouds, waves continue rolling across dark water. Above them, countless droplets remain suspended between Earth and space. Each droplet is caught in a balance. Gravity encourages it downward. Air currents encourage it upward. For a time, neither side fully wins. The cloud persists, patient, quiet, temporary. Nothing in the atmosphere remains unchanged forever. Cloud droplets collide. They merge. They grow larger. Some clouds contain ice crystals. Others contain liquid water. Many contain both. Within these environments, countless interactions occur every second. Tiny encounters, tiny exchanges, tiny rearrangements. Gradually, some droplets become heavy enough that the surrounding air can no longer support them. Their descent begins. Rainfall is not a sudden event. It is the visible conclusion of millions upon millions of microscopic decisions made by nature. A droplet falls, then another, then thousands more. The cloud releases part of itself back toward the surface. Rain often feels peaceful because it reveals a process that is usually hidden. The atmosphere is always active. Air is always circulating. Energy is always flowing. Water is always changing state. Rain simply allows us to witness part of that immense machinery. Listen carefully to rainfall, and you hear countless impacts. Droplets meeting leaves, droplets meeting rooftops, droplets meeting rivers already flowing toward the sea. Each sound is small. Together, they become one of the most recognizable sounds on Earth. A natural form of white noise. A reminder that movement continues even in darkness. Perhaps this is why rain feels comforting to many people. Its rhythm suggests continuity. The world continues its work without requiring our participation. Clouds gather. Rivers flow. Oceans breathe moisture into the air. The cycle continues, and we are allowed, for a little while, simply to rest. Somewhere tonight, rain is crossing a forest. Somewhere it is touching an empty road. Somewhere it is falling into the open ocean, returning to the place from which much of it originally came. And somewhere above all those places, beyond the clouds, beyond the atmosphere itself, the stars continue shining in silence. The droplets do not know where they are going. The clouds do not know how they appear from below. The oceans do not hurry toward any destination. Nature simply unfolds according to countless small interactions, repeated across enormous spans of time. And perhaps there is comfort in that. The universe does not rush. Galaxies rotate slowly. Mountains rise slowly. Rivers carve valleys slowly. Rain itself is often nothing more than patience becoming visible. As the night grows deeper and the sounds of the world become softer, imagine those droplets continuing their endless journeys through darkness, through cloud, through ocean, through river, through mist. A cycle older than memory, older than civilization, older than every story ever told beneath the shelter of a roof while rain whispered outside. And still, it continues. The atmosphere is often described as a layer of air surrounding the earth. A simple definition, accurate. And yet it does not quite capture the immense, quiet complexity of what exists above us. The atmosphere is not merely a blanket wrapped around a planet. It is a moving ocean, a transparent sea extending upward into darkness, an invisible landscape of currents and boundaries, of temperature and pressure, of moisture and motion. Every rainfall begins somewhere within this vast aerial ocean. Most days, people move through their routines beneath it without noticing. Cars travel roads. Lights glow in apartment windows. Ships cross distant waters. Birds drift between rooftops and trees. And overhead, thousands of meters above the ground, rivers of air continue flowing across continents. These atmospheric rivers are among the largest transport systems on Earth. Though invisible, they carry enormous quantities of water vapor. More water may pass through the sky above a region than through some of the rivers below it. The movement is continuous, patient, ancient. A traveler standing alone beside a shoreline at night might look across the dark ocean and imagine stillness. Yet nothing is truly still. The waves move, the clouds move, the atmosphere moves. Even the earth beneath their feet rotates quietly through space. Rain emerges from motion, hidden inside apparent calm. And perhaps many things in life are like that. Great changes often begin as nearly invisible movements. Long before the first raindrop falls, the atmosphere is already preparing. Warm air possesses an important property. It can contain more water vapor than cold air. This simple fact influences nearly every cloud and storm on Earth. As sunlight warms oceans and land surfaces, nearby air warms as well. Warm air becomes less dense, and because it is less dense, it tends to rise. The process unfolds so gradually that it often escapes notice. Yet, entire weather systems depend upon it. A parcel of warm air begins ascending. As it rises, atmospheric pressure decreases. With less surrounding pressure, the air expands. Expansion causes cooling. The higher it climbs, the cooler it becomes. Eventually, temperatures reach a point where water vapor begins condensing into tiny droplets. Clouds emerge from invisible moisture becoming visible. The transformation feels almost magical. Yet it is governed by straightforward physics, molecules exchanging energy, temperature shifting, pressure changing, invisible becoming visible. A cloud is not created all at once. It grows. A few droplets appear, then more, then countless others. Gradually, a faint patch of whiteness develops against the sky. The process resembles memory. One thought arrives, another follows, connections form. Something substantial emerges from countless small parts. Over quiet landscapes, small fair-weather clouds drift through daylight. These are among the atmosphere's gentlest creations. They float across fields and forests, across rivers and towns. Their shadows glide over hillsides. Animals continue grazing beneath them. Birds cross between them, and from a distance, they appear almost motionless. Yet even these peaceful clouds contain ongoing activity. Droplets forming, droplets evaporating, air rising, air sinking. Nothing remains fixed. Everything participates in a subtle exchange. Far beneath the surface of the oceans, darkness stretches through vast underwater distances. Creatures move slowly through cold water. Sediment settles toward the seabed. Currents circulate through regions untouched by sunlight. Above those same oceans, evaporation never fully stops. Day after day, year after year, millennium after millennium, the sea contributes moisture to the atmosphere. The atmosphere returns water through rain. Together, they participate in one of Earth's longest conversations, a conversation conducted entirely through movement. The hydrological cycle is sometimes called the water cycle, a simple name for an astonishing process. Water leaves the ocean, forms clouds, falls as rain, flows through rivers, freezes into ice, melts again, returns to the sea, and begins once more. No beginning, no ending, only continuity. A droplet falling tonight may have once existed inside an ancient glacier. It may have drifted through prehistoric clouds. It may have passed through rivers that vanished thousands of years ago. The molecules themselves endure. Their journeys continue. There is something strangely comforting about this. Human lives are brief. Civilizations rise and fall. Languages change. Borders shift. But the cycle of water continues through all of it. Rain that fell upon ancient forests follows the same physical laws as rain that falls upon modern cities. The atmosphere remembers no distinction. It simply continues. Elsewhere on Earth, mountain ranges interrupt the movement of air. When moist air encounters a mountain, it cannot pass directly through solid rock. Instead, it rises. Higher, colder, clouds form. Rain develops. This phenomenon helps explain why some mountain slopes receive abundant rainfall, while other regions remain comparatively dry. The atmosphere interacts with geography in elegant ways. Mountains shape clouds. Clouds shape rivers. Rivers shape landscapes. Landscapes influence ecosystems. Everything affects something else. A chain of influence stretching across scales both large and small. Imagine standing in a remote valley before dawn. The sky remains dark. The world feels suspended between night and morning. A cool wind moves gently through trees. Above the mountains, clouds gather. Invisible moisture transported from distant oceans begins transforming into rain. The process feels immediate, yet Its origins may lie hundreds or thousands of kilometers away. Weather is local. Its causes are often global. The atmosphere connects distant places. Moisture evaporating from tropical seas may eventually fall as rain in faraway forests. A storm crossing one region may influence conditions elsewhere days later. The sky links landscapes together, not visibly, not dramatically, but continuously. The clouds themselves come in many forms. Some spread as thin veils across enormous distances. Others rise into towering structures, reaching high into the atmosphere. Each type reveals information about conditions above. Clouds are messages written in moisture and temperature. Scientists have spent centuries learning how to read them. The names themselves possess a gentle rhythm: cirrus, stratus, cumulus, nimbus, words derived from observation, attempts to classify shapes drifting across the sky. Long before satellites existed, people looked upward and searched for patterns. They noticed recurring forms, recurring behaviors, recurring relationships between clouds and weather. Science often begins this way, with careful attention, with patient observation, with curiosity sustained over time. Perhaps one reason clouds inspire reflection is their impermanence. No cloud remains exactly as it was. Shapes appear, transform, disappear. The atmosphere sketches temporary paintings across the sky, always changing, never preserved. A cloud viewed tonight will never exist again in precisely the same arrangement. Its droplets will continue elsewhere. Its structure will dissolve. Its moisture will move onward. The cloud's existence is real, yet fleeting, and perhaps there is a lesson hidden within that. Many meaningful things are temporary: sunsets, seasons, conversations, moments of quiet understanding. Their impermanence does not diminish their value. It may enhance it. The atmosphere demonstrates this truth every day. Far above commercial aircraft, near the edge of space, the air becomes exceedingly thin. Temperatures drop dramatically. The familiar environment of the lower atmosphere gradually gives way to a region where conditions become increasingly alien. Yet even there, the influence of water remains. Tiny ice crystals may form, delicate structures shaped by molecular geometry. Snowflakes begin their journeys in these cold environments. Each one develops according to local conditions: temperature, humidity, time. The resulting patterns often appear impossibly intricate, and yet they emerge naturally from simple physical principles. Complexity arising from simplicity, order emerging from countless interactions. Nature performs this transformation repeatedly, not through intention, not through planning, but through consistent laws operating over immense spans of time. Snowflakes are reminders that beauty can emerge from ordinary ingredients: water, cold air, patience, nothing more. And yet the results can seem extraordinary. The night sky above a snow-covered landscape possesses a unique silence. Sound softens. Distance becomes difficult to judge. Moonlight reflects from countless ice crystals. The world appears transformed. Yet beneath the beauty lies familiar physics: water changing state, energy moving between molecules, the same processes that help create rain, different conditions, different outcomes. One underlying system. Weather often appears unpredictable, and in some respects it is. Small differences can grow over time. Tiny variations in atmospheric conditions may influence future developments. This sensitivity makes forecasting challenging. Even with advanced computers and global observation networks, uncertainty remains, not because science has failed, but because the atmosphere is extraordinarily complex. Billions upon billions of interactions occur simultaneously. The challenge is immense, and yet forecasting has improved dramatically. Modern meteorology combines observation, mathematics, physics, and computing. Satellites monitor cloud formations. Weather balloons sample atmospheric conditions. Ocean buoys collect data from remote regions. Together, they help scientists understand the ever-changing state of the atmosphere. It is a remarkable achievement, a global effort devoted to understanding the sky. And still, despite all our knowledge, there remains something quietly mysterious about watching clouds gather in the distance. Knowledge and wonder coexist comfortably. One does not eliminate the other. Sometimes understanding deepens appreciation. The more we learn about rain, the more extraordinary it becomes. A droplet seems simple, yet its journey may involve oceans, sunlight, atmospheric circulation, condensation nuclei, cloud dynamics, gravity, and landscape interactions. A small event connected to vast systems, just as individual lives are connected to larger stories. The stars continue shining beyond the atmosphere. Their light crosses unimaginable distances, years, centuries, millennia. Eventually, some of that light reaches Earth. It passes through layers of air, through clouds, through falling rain, and arrives at waiting eyes. The universe often communicates through gentle processes, not explosions, not dramatic events, but quiet persistence. Light traveling, water cycling, planets orbiting, galaxies turning slowly through darkness. Rain belongs to that family of slow phenomena, a reminder that powerful forces need not be loud. As midnight deepens across parts of the world, countless clouds drift unseen above sleeping cities. Streetlights glow below. Rivers continue their journeys. The atmosphere breathes overhead. Somewhere, rain is beginning. Elsewhere, rain is ending. Some clouds are forming. Others are dissolving. The cycle never pauses. Not for nations. Not for calendars. Not for generations. Only movement. Only change. Only continuity. And perhaps, beneath all the complexity of atmospheric science, there is a comforting realization. The same earth that supported ancient forests still supports modern life. The same water cycle that nourished long-extinct ecosystems continues today. The same clouds observed by people centuries ago still drift overhead in familiar forms. The world changes constantly, and yet some patterns endure. Rain falls, rivers flow, oceans evaporate, clouds gather. The atmosphere continues its endless conversation with the planet below. And through the quiet hours of the night, while much of humanity sleeps, that conversation carries on in whispers of moisture, temperature, gravity, and time. Unseen, unhurried, ancient, patient, like the rain itself. There are moments just before rain begins when the atmosphere seems to hesitate. The light becomes softer. Distant colors appear muted. The air feels different against the skin. Nothing dramatic has happened. No sudden transformation. And yet the world seems aware that something is approaching. Science can explain much of this sensation. Changes in humidity alter the way heat moves from our bodies. Cloud cover changes the character of sunlight. Shifting air masses influence pressure and temperature. Our senses quietly register these differences long before conscious thought notices them. The atmosphere announces its intentions gently, long before the first raindrop falls. Humidity is one of the most important ingredients in the story of rain. It represents the amount of water vapor present in the air. Though invisible, humidity shapes daily experience in subtle ways. It influences comfort. It influences evaporation. It influences cloud formation. And ultimately, it influences rainfall itself. Warm tropical air can contain enormous quantities of moisture. In some regions, the atmosphere becomes almost ocean-like in its richness. The air feels dense, soft, heavy with unseen water. By contrast, cold polar air holds far less moisture. The atmosphere changes character across the planet, like an enormous living landscape. Yet, despite these differences, the same physical laws apply everywhere. The molecules do not recognize national borders. They do not recognize languages or cultures. They respond only to temperature, pressure, energy, and motion. There is something quietly humbling about that. Nature operates through principles far older than any human system. The atmosphere belongs to everyone and to no one. Over vast tropical oceans, sunlight pours onto the sea surface day after day. Water absorbs energy. Evaporation increases. Warm, moist air rises into the sky. The process may seem gentle from a human perspective, yet the scale is extraordinary. The amount of energy exchanged between ocean and atmosphere each day is almost beyond imagination. Entire weather systems draw their strength from this transfer. The atmosphere is powered by differences. Differences in temperature, differences in pressure, differences in solar heating. Without these contrasts, weather would become far quieter. The winds would weaken. Cloud formation would change. Rainfall patterns would transform. Much of Earth's atmospheric activity exists because energy is distributed unevenly across the globe. Near the equator, sunlight arrives more directly. Near the poles, sunlight arrives at lower angles. This imbalance creates movement, and movement creates weather. Far above tropical waters, towering clouds often begin as modest upward currents of warm air. A small rising column, almost insignificant at first, yet given sufficient moisture and instability, these clouds may grow into immense structures reaching many kilometers into the atmosphere. These are among the tallest clouds on Earth, great vertical cities of vapor and ice. Their upper regions can spread outward into broad anvils visible from extraordinary distances. Seen from space, they resemble vast white islands floating upon the atmosphere. Seen from below, they can appear almost architectural, monuments constructed entirely from water. Within these clouds, countless processes occur simultaneously. Droplets collide, ice crystals form, air accelerates upward and downward, electrical charges separate, rain develops. The cloud becomes a world unto itself, a temporary environment governed by atmospheric physics. And yet, even the largest storm cloud remains temporary, its existence measured in hours rather than centuries, a reminder that size and permanence are not the same thing. Some of the most imposing structures in nature are also among the most fleeting. Long before modern meteorology, people watched storms with fascination. They observed patterns. They noticed seasonal rhythms. They learned which cloud formations preceded rainfall. Knowledge accumulated slowly, generation after generation, observation after observation. Science did not appear suddenly. It emerged through patience, the same patience found throughout nature itself. The atmosphere rewards those willing to observe carefully. A cloud's shape contains information. Its movement contains information. Its height contains information. The sky is constantly communicating. The language is subtle, but it is always present. Imagine standing on a quiet coastline during the evening. The horizon stretches into darkness. Clouds drift overhead. Waves move rhythmically beneath moonlight. A distant storm flashes silently beyond the curvature of the earth. For a moment, the atmosphere reveals its vastness. The sky no longer feels like a ceiling. It feels like an ocean extending upward, a realm of depth and distance, a place where invisible currents travel thousands of kilometers, where moisture journeys between continents, where storms are born and fade away. The scale becomes almost difficult to comprehend. Human experience is local. Weather is planetary. The atmosphere connects every region of Earth. A molecule of water evaporating from the Pacific Ocean may someday become part of a cloud over a mountain range. It may fall into a river, flow into another sea, evaporate again. Its journey may continue for centuries. There is no final destination, only participation in an ongoing cycle. This continuity is one of the defining characteristics of nature. Nothing is truly isolated. Everything belongs to larger systems. Rain illustrates this beautifully. A droplet landing upon a leaf appears separate, individual, self-contained, yet its history stretches backward through oceans, clouds, sunlight, and atmospheric circulation. Its future extends beyond the moment of impact. The droplet will continue moving, changing, returning. Nature rarely stops. It transforms. Elsewhere in the atmosphere, tiny particles continue performing an essential role. Without them, cloud formation would become far more difficult. These particles are known as condensation nuclei, a technical term for remarkably small objects, dust grains, salt crystals, microscopic fragments suspended in the air. Water vapor often requires such surfaces upon which to condense. Clouds depend upon these tiny foundations. The relationship is fascinating. Something as enormous as a cloud may depend upon particles almost too small to imagine. Great structures built upon minute beginnings. The universe often works this way. Galaxies emerge from small fluctuations. Forests emerge from seeds. Clouds emerge from microscopic particles. Large outcomes frequently originate in small events. The atmosphere teaches this lesson repeatedly. On certain mornings, fog settles across valleys and coastlines. Roads disappear into whiteness. Trees emerge only as silhouettes. Distances become uncertain. The familiar world feels transformed. Fog is essentially a cloud touching the ground, a simple concept, yet the experience can feel strangely dreamlike. The atmosphere descends into the human world. The boundary between sky and earth softens. Everything becomes quieter, more intimate, more mysterious. Sound behaves differently in fog. Visibility changes. Perspective shifts. Travelers move carefully through the pale landscape. And overhead, unseen beyond the mist, the larger atmosphere continues its endless motions. Fog often inspires reflection because it conceals. It limits what can be seen. The distant horizon disappears. Only nearby details remain visible. Perhaps there is comfort in this. Human beings often seek certainty about distant futures. Yet life is frequently experienced one step at a time. Like walking through fog, the atmosphere occasionally mirrors our own experience, revealing enough for the present moment, leaving the rest hidden. As night deepens, temperatures frequently fall. The ground loses heat. Air near the surface cools. Moisture may condense upon grass, leaves, rooftops, and stones. Dew forms, tiny droplets appearing silently during darkness. No storm, no clouds required, only cooling air and sufficient moisture. By morning, entire landscapes may sparkle with droplets reflecting sunlight. The process is gentle, almost invisible, yet it demonstrates once again how readily water changes form. The atmosphere is full of transitions, vapor becoming liquid, liquid becoming ice, ice becoming vapor, matter shifting between states as conditions change. The transformations never truly stop. Even now, as you listen, countless molecules somewhere on Earth are evaporating into the air. Others are condensing into clouds. Others are falling as rain. Others are freezing inside snowstorms. The cycle is continuous, a planetary rhythm older than humanity itself. Far to the north and south, polar regions experience conditions unlike those of tropical oceans. The air is colder, the sunlight weaker, the seasonal cycles more extreme, and yet water remains central there as well. Ice sheets store enormous quantities of frozen water. Glaciers move with almost unimaginable slowness. Snow accumulates year after year, layer upon layer, century upon century. Some ice preserves atmospheric records stretching back hundreds of thousands of years. Tiny bubbles trapped within glaciers, contain ancient air, frozen samples of past atmospheres, a remarkable archive, the Earth quietly recording its own history. Scientists studying ice cores can learn about climates long vanished, temperatures from distant ages, changes in atmospheric composition, patterns extending far beyond recorded history. Rain, snow, ice, and atmosphere become storytellers, their records preserved in natural archives. Nature remembers in unexpected ways. A glacier may appear motionless, yet it moves, slowly, relentlessly. Its progress measured in centimeters or meters rather than kilometers. Human attention often overlooks such gradual change, yet slow processes shape the world. Mountains erode, continents shift, rivers carve valleys, climate evolves. Rain participates in these transformations. Patiently, persistently. A single storm rarely reshapes a continent, but millions of storms over millions of years certainly can. Small actions repeated over vast spans of time become powerful. The atmosphere demonstrates this principle everywhere. Raindrops seem fragile, individually insignificant, yet together they fill lakes, feed rivers, sustain forests, influence ecosystems, support civilizations. Fragility and power coexist. One does not exclude the other. The same is true throughout nature. The stars above may appear permanent, yet they evolve. Clouds may appear delicate, yet they influence entire regions. Human lives may be brief, yet they contribute to histories extending beyond individual lifetimes. Scale is complicated. Meaning is not always determined by size. Some of the most important forces operate quietly, in darkness, without announcement. Consider a remote forest during rainfall. Leaves collect droplets, moss absorbs moisture, streams swell gently. The atmosphere delivers water gathered from distant places. No audience observes. No headlines record the event, yet the forest depends upon it. Countless organisms depend upon it. Nature performs essential work without recognition. Much of the world operates this way. The most important processes are often the least visible. Breathing, growing, circulating, flowing. Rain belongs to this category, a familiar phenomenon concealing extraordinary complexity. As midnight gradually gives way to deeper night, clouds continue drifting above sleeping landscapes. Cities glow softly beneath them. Mountain peaks disappear into darkness. Oceans reflect faint traces of starlight. And overhead, moisture continues its endless migrations through the atmosphere. Some droplets are beginning journeys. Others are concluding them. Some clouds are growing. Others are dissolving. The cycle remains unbroken, patient, ancient, quietly beautiful. And somewhere beyond the reach of any storm, beyond the atmosphere itself, the universe continues expanding into immense darkness. Galaxies drift, stars burn, planets orbit, while below, on one small world, rain continues falling through the night. A simple event, an ordinary event. And yet, when viewed carefully, one of the most remarkable stories in nature. There is a particular kind of silence that arrives during a steady rain. Not the complete absence of sound, Quite the opposite. Rain creates its own world of sound, a continuous texture, a gentle curtain of countless tiny impacts, and somehow, within that soft complexity, many other noises seem to fade away. Roads become quieter, distant conversations disappear, the edges of the world feel softened. Acoustically, rain changes the environment. Its countless droplets scatter and absorb sound in subtle ways. Its steady rhythm masks irregular noises. The atmosphere itself becomes part of the landscape of listening. For thousands of years, human beings have rested beneath this sound. Generations separated by centuries have listened to rainfall striking roofs made from different materials: wood, stone, clay, metal. Yet the feeling remains surprisingly similar. A sense of shelter, a sense of pause, a reminder that nature continues moving beyond the walls around us. And while rain feels intimate when heard from indoors, the processes that create it operate on scales that reach across oceans and continents. This contrast is one of the most fascinating aspects of atmospheric science. The local and the global exist together. A droplet striking a windowsill may have begun its journey thousands of kilometers away. A small sound connected to a planetary cycle. The atmosphere is full of such connections, invisible relationships linking distant places. Consider the trade winds. These persistent air currents flow across vast regions of the earth. For centuries, they guided sailing ships. Long before satellites and weather models existed, navigators learned their patterns. The winds became pathways across oceans, reliable companions in uncertain journeys. Today, we understand them through physics. The uneven heating of the planet drives large-scale circulation. Warm air rises near the equator. Cooler air descends elsewhere. The rotation of the Earth influences movement. Complex patterns emerge. The result is a global atmospheric system operating continuously. Day and night, season after season, century after century. Moisture travels within these currents. Clouds form and disperse. Rainfall patterns develop. The atmosphere behaves less like a collection of isolated weather events and more like a single interconnected system, a living network of motion. One region influences another. One ocean influences distant continents. The sky above every place is connected to skies elsewhere. This idea can feel strangely comforting. The atmosphere ignores many of the divisions humans create. The clouds passing overhead today may cross several countries before dissolving. The moisture in tomorrow's rainfall may have originated beyond the horizon. Nature moves freely through distances that often seem immense to us. Far above the oceans, sunlight continues its quiet work. Energy enters the Earth system. Water evaporates. Air warms. Clouds develop. The cycle appears repetitive, and it is. But repetition in nature is not monotony. It is renewal. The tides repeat. The seasons repeat. Day and night repeat. Yet each occurrence is slightly different. A new arrangement of conditions. A new combination of influences. The atmosphere never produces the exact same moment twice. Every rainfall is unique. Every cloud formation exists only once. Every storm follows its own path through time. This uniqueness emerges from complexity. Even tiny differences matter. A slight variation in temperature, a subtle shift in wind direction, a small change in humidity. Over time, these differences may grow. The atmosphere possesses a remarkable sensitivity. Scientists often study this characteristic through the mathematics of dynamic systems. Small causes can sometimes contribute to large outcomes, not always, but often enough to make weather forecasting one of the most challenging scientific tasks. The atmosphere contains countless interacting variables, and yet, despite this complexity, broad patterns remain understandable. Certain regions are wetter, certain regions are drier, certain seasons favor rainfall, certain conditions favor storms. Order and unpredictability coexist. The atmosphere is structured, but never rigid, predictable in some ways, mysterious in others. Perhaps this balance contributes to its enduring fascination. Human beings often seek certainty. Nature frequently offers probability instead. Clouds provide possibilities, not guarantees. The future remains partially open. Even in science, uncertainty is not necessarily a flaw. Sometimes it is an honest reflection of complexity. Elsewhere on Earth, enormous storm systems slowly rotate over oceans. Viewed from space, they reveal spiraling structures of extraordinary beauty. Bands of clouds curve across vast distances. Rainfall spreads outward from central regions. The entire system turns with elegant geometry. These storms derive energy from warm ocean waters. Heat stored in the sea becomes motion in the atmosphere. The transfer is subtle at the molecular level, yet immense in total. A reminder that countless small exchanges can create powerful outcomes. Energy moves constantly through nature. From sunlight to ocean, from ocean to atmosphere, from atmosphere to rainfall. The cycle never truly ends. Imagine drifting above the earth in darkness, far beyond the atmosphere, far above the clouds. From that perspective, storms appear almost delicate. Thin swirls of white suspended over a blue planet. Beautiful, fragile, temporary. The scale shifts dramatically. What feels enormous from the surface appears small from orbit. Perspective changes understanding. This is true in science, and perhaps in life as well. Many worries that feel overwhelming in the moment may appear differently when viewed from a greater distance. The atmosphere offers repeated lessons in perspective. A cloud may seem vast when standing beneath it, tiny when viewed from space. A raindrop may seem insignificant, yet millions of droplets sustain ecosystems. Size alone rarely tells the whole story. Far beneath the clouds, rivers carry rainfall toward the sea. These rivers represent another stage of the water cycle. Gravity gathers water from landscapes. Streams join larger streams. Rivers widen. Eventually, many return their water to the oceans. The journey can be surprisingly long. A raindrop falling upon a mountain may spend months or years moving through watersheds before reaching the sea. Some water enters groundwater systems. Some nourishes forests, some evaporates once more before completing its journey. The paths vary. The cycle continues. There is no single route, only participation in a larger process. Groundwater deserves special attention. Much of Earth's freshwater exists beneath the surface, hidden from view, moving slowly through rock and soil. Rainfall replenishes many of these underground reserves. The connection between sky and subsurface may seem indirect, yet it is profound. Water falling from clouds today may eventually become part of aquifers supporting ecosystems and communities far into the future. Rain often appears temporary. Its consequences may endure for years. Nature frequently operates through delayed effects. Seeds wait beneath soil. Glaciers preserve ancient snow. Groundwater moves slowly through hidden channels. Not all processes reveal their outcomes immediately. Patience is woven into the fabric of the planet. A forest understands patience. Trees may spend decades reaching maturity. Some survive for centuries. Throughout their lives, rainfall sustains them. Water moves upward through roots, through trunks, through branches, eventually reaching leaves high above the ground. There, another remarkable process unfolds: transpiration. Plants release water vapor into the atmosphere. Forests participate directly in atmospheric cycles. They are not merely recipients of rainfall, they are contributors. The relationship is reciprocal. Clouds nourish forests. Forests help nourish clouds. The Earth system is full of such partnerships, mutual influences, circular relationships, feedback loops extending across landscapes. In some tropical regions, vast forests contribute significant amounts of moisture to the atmosphere. Rain falls, plants absorb water. Water returns to the air. New clouds form. The cycle repeats. The forest and atmosphere engage in an ongoing exchange, a quiet collaboration spanning millions of years. Long before humans studied these interactions scientifically, they were already shaping climates and ecosystems. Nature often develops complexity without instruction. Order emerges through countless interactions over immense periods of time. The result can seem almost purposeful, yet it arises naturally. The atmosphere requires no conductor. The cycle requires no manager. Physics provides the framework. Nature performs the rest. Night deepens further. Across deserts, temperatures begin falling. Across oceans, winds continue moving moisture. Across mountain ranges, clouds gather in darkness. Across forests, leaves collect dew. The atmosphere remains active while much of humanity sleeps. A global system operating without interruption. Somewhere, weather balloons ascend into the night sky, carrying instruments through layers of air, measuring temperature, pressure, humidity, wind. Each observation contributes to a larger understanding. Science often advances through accumulation. Small measurements collected consistently, patterns emerging gradually, knowledge built piece by piece. There is something admirable about this approach. Patient observation, careful attention, a willingness to learn from subtle details. The atmosphere rewards such patience. Its secrets are rarely hidden. They are simply dispersed across immense scales. Scientists gather clues from satellites, aircraft, radar systems, ocean buoys, ground stations. Each provides a fragment of the larger picture. Together, they reveal the state of a moving planet, a world constantly exchanging energy and water. Rain remains one of the most visible outcomes of these exchanges, simple to observe, profound in significance. The next time rain falls upon a quiet street, it may seem like an ordinary event, and in one sense, it is. Rain happens every day somewhere on Earth, but ordinary does not mean unremarkable. The familiar often conceals extraordinary depth. A falling droplet embodies sunlight gathered from distant oceans, atmospheric circulation spanning continents, cloud microphysics occurring far above the ground, gravity completing the final stage of a long journey, an entire chain of events culminating in a single impact. The universe is full of such hidden complexity. Stars shine because of nuclear fusion. Mountains exist because of geological forces. Rain falls because of countless interactions between water, air, energy, and time. Simple observations connected to immense processes. As the hours pass quietly onward, imagine the atmosphere as an endless ocean overhead. Not empty space, not merely air, but a realm of motion. A place where moisture drifts through darkness, where clouds form and dissolve, where storms are born, where rain begins its descent toward waiting rivers and forests and seas, above sleeping towns, above silent deserts, above lonely islands surrounded by moonlit water. The atmosphere continues its ancient work, patiently, faithfully, without haste, and through all of it, the rain remains what it has always been, a conversation between ocean and sky, a cycle of return, a reminder that nothing in nature truly stands alone. Everything flows into something else. Everything belongs to a larger story, and the story continues through the night. Long before a raindrop reaches the ground, it exists in a world almost unimaginably small. A cloud may seem vast from below. It may stretch across valleys, cover entire cities, cast shadows over mountains and oceans. Yet, the individual droplets within a cloud are often tiny beyond ordinary human experience. Many are smaller than the width of a human hair. If one could somehow drift among them, suspended inside the cool interior of a cloud, the environment would feel less like a collection of falling drops and more like a pale mist stretching into every direction. Visibility would fade. Light would scatter softly. Tiny droplets would float all around, carried by invisible currents. The cloud would feel less like an object and more like a place, a temporary landscape built from water and air. Scientists sometimes describe clouds through measurements and equations, and these descriptions are important. They reveal the physical mechanisms involved, but there is also something quietly remarkable about imagining the interior of a cloud itself, a realm suspended between sky and earth, a place where water is preparing for another stage of its journey. Within this misty environment, droplets are constantly interacting. They collide, separate, merge, evaporate, reform. Nothing remains static. The cloud is alive with motion, not biological life, but dynamic activity. Countless tiny events occurring every second. Most of these interactions are invisible to us, yet they determine whether rainfall will eventually occur. A cloud cannot simply decide to become rain. Certain conditions must emerge. Droplets must grow. They must accumulate enough mass that gravity begins to overcome the upward movements of air surrounding them. Only then does descent become possible. The process is surprisingly delicate. Many droplets form and disappear without ever reaching the ground. Some evaporate while still suspended. Others become incorporated into different cloud structures. The atmosphere is constantly experimenting with possibilities. Not every cloud becomes rain. Not every journey reaches completion. There is something familiar about that. Nature rarely follows perfectly direct paths. Growth often involves detours. Transformation often includes reversals. Progress is not always linear. The atmosphere demonstrates this with quiet consistency. Far above mountain ranges, where temperatures can become extremely cold, another process unfolds. Ice crystals begin to form. These crystals play a profound role in many precipitation systems. In certain clouds, water droplets remain liquid even below freezing temperatures. This may sound surprising. Yet, under specific conditions, liquid water can persist in a supercooled state. Waiting, balanced delicately between possibilities. Then an ice crystal forms, perhaps around a tiny particle suspended in the air. Once present, the crystal begins attracting water vapor. It grows, gradually, patiently, molecule by molecule. The resulting process helps create snowflakes and contributes to rainfall as well. The atmosphere often relies upon these subtle interactions, small beginnings leading to larger outcomes. Imagine a single ice crystal forming high within a cloud. Tiny, fragile, nearly invisible, and yet capable of influencing the development of precipitation over an entire region. The scale of influence in nature can be surprising. Small things matter, often more than they appear to. Elsewhere in the atmosphere, winds continue moving across enormous distances. Air that was once above a warm ocean may eventually pass over forests, mountains, grasslands, cities. Its journey reflects the interconnected nature of the planet. Nothing remains isolated for long. The atmosphere is a traveler, always moving, always redistributing energy and moisture. Ancient sailors understood this in practical ways. Their survival often depended upon reading the sky, cloud formations, wind direction, changes in pressure, subtle clues revealing what might happen next. Modern technology has expanded our understanding enormously. Yet there remains something timeless about watching clouds gather on a distant horizon. The experience connects us to generations of observers stretching backward through history. Human beings have always looked upward, always wondered, always sought patterns. The sky invites attention, perhaps because it changes continuously, or perhaps because it reminds us of our place within something larger. At night, this feeling can become especially powerful. A person standing beneath a dark sky may feel both small and connected. The stars reveal immense distances. The atmosphere reveals constant motion. Together, they create a sense of scale difficult to find elsewhere. Rain belongs to that scale, a local event embedded within planetary systems. Familiar experience connected to global cycles. Far out at sea, beyond shipping routes, and distant from coastlines, rainfall sometimes falls directly back into the ocean. No fields are watered, no rivers replenished, no cities experience the storm. The rain simply returns to its source, ocean to atmosphere, atmosphere to ocean, a complete loop, quiet and unnoticed. Much of nature unfolds beyond human observation. Rain falls over remote waters. Snow accumulates in isolated mountains. Clouds drift across uninhabited regions. The planet does not require an audience. Its processes continue regardless. There is something peaceful about that realization. The world is larger than our attention, larger than our concerns, larger than our schedules and plans. Rain reminds us of this gently. A storm passing across the ocean tonight follows the same physical principles as one crossing a crowded city. Nature does not distinguish between famous places and forgotten ones. The atmosphere treats all landscapes with equal impartiality. Clouds gather where conditions permit. Rain falls where physics allows. The cycle continues over millions of years, across countless generations. The consistency is almost comforting. Human history often feels turbulent, uncertain, rapidly changing. The water cycle operates differently. It evolves over geological timescales. Its rhythms persist through eras. Ancient animals experienced rainfall. Ancient forests experienced rainfall. Ancient oceans contributed moisture to ancient clouds. The details chain. The cycle endures. Some of the oldest evidence for water on Earth stretches back billions of years. The planet has hosted water for much of its existence. Oceans formed, clouds developed, rain fell, the atmosphere evolved. Yet throughout these transformations, water remained one of the defining features of the world. Without it, Earth would be profoundly different, perhaps lifeless, perhaps unrecognizable. Water shapes climate, geology, biology, human civilization. Its influence extends everywhere. And rain represents one of the most visible expressions of that influence. A bridge between atmosphere and surface. A transfer between sky and land. A visible moment within a much larger system. As clouds move across continents, they encounter different environments. Warm regions, cold regions, dry regions, humid regions. Each influences cloud behavior in unique ways. The atmosphere responds continuously to local conditions, like a traveler adapting to changing landscapes. No two journeys are identical, yet common patterns emerge. Science seeks these patterns, not because every detail can be predicted, but because understanding becomes possible through recurring relationships. The atmosphere is complex, not chaotic in the everyday sense, complex in the scientific sense, rich with interactions, filled with feedbacks, governed by consistent laws, producing endlessly varied outcomes. This combination of order and variation is one of nature's most beautiful qualities. The laws remain stable. The results remain creative. A forest never grows the exact same way twice. A coastline never experiences identical waves. A cloud never forms the same shape again. Nature repeats themes rather than copies. Variation emerges naturally. Rain embodies this principle. Each storm is unique, yet all storms belong to the same larger story, the same cycle, the same planetary rhythm. Deep beneath the oceans, currents move through darkness. These currents transport heat around the globe. Their influence extends far beyond the sea itself. Ocean circulation affects atmospheric circulation. Atmospheric circulation affects rainfall. Rainfall affects rivers, ecosystems, and climate. Connections extend across enormous distances. The Earth system functions as an integrated whole. Sometimes these relationships are difficult to perceive because they operate across scales larger than daily experience. Yet they are always present. A change in ocean temperature may influence cloud formation months later. A shift in atmospheric circulation may alter rainfall patterns across entire regions. Nature weaves countless processes together. The resulting tapestry is intricate beyond easy description. And still, the experience of rain remains simple. A cool drop on skin, a sound against a roof, a darkening path through a garden. The beauty of science lies partly in this contrast. Profound complexity producing familiar experiences, the ordinary connected to the extraordinary. A child watching rain from a window and a scientist studying atmospheric dynamics are observing the same phenomenon. Different perspectives, different levels of detail, one reality. Knowledge adds depth without removing wonder. In fact, wonder often grows with understanding. The more we learn about rain, the more remarkable it becomes. Every droplet represents a journey. Every cloud represents a process. Every storm represents an exchange of energy spanning vast distances. The atmosphere transforms sunlight and water into weather. Day after day, year after year, without rest, without interruption. Night continues across much of the planet now. Cities glow beneath cloud cover. Ships cross dark oceans. Forests stand beneath drifting mist. Mountain peaks disappear into the shadows, and overhead, invisible currents continue carrying moisture through the atmosphere. The work never stops. Clouds continue forming. Droplets continue growing. Rain continues falling somewhere beyond the horizon. The cycle remains ancient, patient, reliable. A conversation between sea and sky that began long before human memory and will likely continue long after every current generation has passed into history. There is comfort in such continuity, not because it makes humanity insignificant, but because it reminds us that we belong to something enduring. The The same atmosphere surrounding us tonight once carried rain over landscapes inhabited by creatures long vanished. The same water cycle that nourished ancient forests nourishes modern ecosystems. The same physical laws guiding clouds today guided them millions of years ago. Some patterns persist. Some stories continue. Rain is one of those stories, and as the night grows quieter still, the atmosphere continues telling it, softly, patiently, one droplet at a time. If one could remain awake through an entire night of steady rainfall, listening without distraction, another pattern might slowly become noticeable. Rain is rarely perfectly uniform. It arrives in waves, moments of softness, moments of greater intensity, a gentle rise and fall, almost like breathing. The atmosphere possesses rhythms within rhythms, small fluctuations nested inside larger ones. The storm itself is part of a weather system. The weather system is part of regional circulation. Regional circulation belongs to global circulation. Every scale connects to another. Nature rarely operates through isolated events. Instead, it weaves layers of influence together. A single raindrop carries the signature of processes occurring across many distances and times. Its immediate fall may last only minutes, yet the conditions that produced it may have been developing for days. The moisture itself may have traveled for weeks. The ocean that supplied that moisture has been interacting with sunlight for billions of years. Every simple event contains a hidden history. The atmosphere is a storyteller in this way, not through words, but through consequences. Each cloud reveals something about what happened before. Each rainfall reflects a sequence of conditions extending backward through time. Long before the first drop appears, the atmosphere has already been writing the beginning of the story. One of the quiet marvels of rain is how it transforms landscapes without changing their identity. A familiar street remains the same street. A forest remains the same forest. A coastline remains the same coastline. And yet everything feels different. Colors deepen. Surfaces reflect light. The air becomes richer with scent. The entire world seems renewed. Water possesses a remarkable ability to alter appearance. Dry stone and wet stone can seem almost like different materials. A dusty road darkens. Tree bark gains contrast. Leaves shine softly beneath cloud-filtered light. Rain reveals details that might otherwise go unnoticed. Perhaps this is one reason people find it soothing. Rain encourages observation. The pace of the world appears slower. Attention settles upon small things. The movement of droplets along glass. The formation of puddles. The sound of water flowing through gutters and streams. Science often begins with this same quality of attention. Careful noticing, patient observation, a willingness to look closely at ordinary things. Rain rewards such curiosity. The deeper one studies it, the more complexity emerges. Consider the shape of a falling raindrop. Many illustrations depict raindrops as teardrop-shaped, a pointed top and rounded bottom. It is a familiar image, yet real raindrops are different. Small raindrops are nearly spherical. Surface tension pulls them into shapes resembling tiny floating spheres. As droplets become larger, air resistance begins altering their form. They flatten slightly. Large droplets may resemble miniature buns or parachutes more than teardrops. The reality is gentler than the popular image. Nature often differs from our assumptions in subtle ways, and discovering those differences can be unexpectedly satisfying. Knowledge does not make the world less beautiful. It reveals new forms of beauty. The true shape of a raindrop is no less elegant than the imagined one. Perhaps more so because it reflects the actual physics governing water and air. A quiet geometry emerging from natural laws. Far above, within clouds, countless droplets are falling and rising simultaneously. Air currents move upward. Gravity pulls downward. The resulting dance can be surprisingly complex. Some droplets may begin descending only to be carried upward again. Others collide and merge. Others evaporate before completing their journeys. Clouds are dynamic environments, places of continual transformation. They resemble ecosystems of motion, temporary worlds suspended in the atmosphere. The deeper scientists have explored these processes, the more intricate they have appeared. Nature rarely reveals a final layer. Every answer often leads to new questions. This is not a weakness of science. It is one of its strengths. Understanding grows. Wonder expands alongside it. The atmosphere remains familiar and mysterious at the same time. Elsewhere in the world, there are regions where rain arrives with remarkable regularity. Season after season, year after year, people build lives around these patterns. Agriculture depends upon them. Forests depend upon them. Entire cultures have developed alongside recurring cycles of rainfall. One of the most significant examples is the monsoon, a word often associated simply with rain, yet the reality is broader. A monsoon is a large-scale seasonal shift in atmospheric circulation. Land and ocean warm at different rates. Pressure patterns change. Winds reverse direction. Moisture moves inland. Rainfall follows. The phenomenon influences the lives of billions of people. Its arrival can transform entire landscapes. Dry regions become green. Rivers swell. Fields awaken. The atmosphere reorganizes itself according to seasonal rhythms. There is something extraordinary about such immense systems, not because they are violent, but because they are dependable. The planet possesses cycles that unfold across months and years with remarkable consistency. The details vary. The overall pattern remains. Earth breathes through seasons. Water moves through those breaths. Long before meteorological science could explain monsoons in detail, people observed them carefully. Generations learned their timing, their signs, their importance. Knowledge accumulated through lived experience. Science eventually provided deeper explanations, yet observation came first. Humanity has always been a student of the sky, even when the lessons were incomplete. Far from tropical regions, other landscapes experience entirely different relationships with rainfall. Deserts, for example, reveal the importance of scarcity. In places where rain rarely falls, each storm carries tremendous significance. Plants adapt, animals adapt, entire ecosystems evolve around limited water availability. When rain finally arrives, transformations can occur with astonishing speed. Seeds dormant for years may germinate. Flowers appear. Dry channels briefly become flowing streams. Life responds to opportunity. Nature remains patient, prepared for moments that may be infrequent. There is wisdom in that patience. Not every process requires constant activity. Sometimes survival depends upon waiting. The desert understands waiting. Clouds understand waiting. Even water vapor may travel long distances before conditions become suitable for rainfall. Nature often values timing as much as action. Above the polar regions, a different story unfolds. Snow dominates many seasons. Ice accumulates. Light changes dramatically throughout the year. And yet the same fundamental molecule remains central. Water changing forms, changing roles, remaining essential. Whether as vapor, liquid, or ice, water links environments that otherwise seem entirely different. Tropical rainforest, mountain glacier, coastal fog, winter snowstorm, summer rainfall, all connected by the same molecular structure, the same physical principles, the same planetary cycle. There is elegance in this simplicity. One molecule participating in countless landscapes. One substance shaping climates, ecosystems, and civilizations. The atmosphere serves as the great intermediary, transporting water between places, facilitating transitions, connecting distant environments. Without the atmosphere, there would be no rain, no clouds, no weather as we know it. The sky itself would become profoundly different. Sometimes familiarity conceals significance. Because the atmosphere surrounds us constantly, it can seem ordinary. Yet, it is one of the most remarkable features of our planet. A thin layer compared to the size of Earth, and yet indispensable, protective, dynamic, alive with motion. When viewed from space, the atmosphere appears surprisingly delicate. A narrow band surrounding the planet, thin compared to the vast darkness beyond. Its fragility becomes apparent, and with that realization comes appreciation. Everything familiar exists beneath this layer. Forests, rivers, mountains, cities, clouds, rain, life itself. A slender envelope of gases makes these experiences possible. The stars beyond remain silent, cold, distant, beautiful in their own way. Yet Earth possesses something unusual. An active atmosphere, liquid oceans, persistent weather, a world where water falls from the sky. Among the countless worlds that may exist throughout the universe, such conditions may be relatively rare. Rain is common to us because we have always known it. But from a cosmic perspective, rainfall may be one of the more extraordinary phenomena in existence. A planet capable of cycling water between ocean and atmosphere. A planet warm enough for liquid water. A planet where clouds drift through blue skies. The familiar becomes remarkable when viewed from sufficient distance. Perspective changes everything. Imagine standing alone beside a quiet lake during rainfall. The surface ripples continuously. Each droplet creates expanding circles. The circles intersect, merge, disappear. For a moment, the lake becomes a visible record of countless impacts, patterns forming and dissolving. The scene resembles larger processes throughout nature, events influencing one another, interactions spreading outward, nothing occurring entirely alone. Single droplet changes the surface. Many droplets transform the entire lake. Scale alters consequence. This principle appears repeatedly throughout atmospheric science. Individual molecules are tiny. Clouds are enormous. Individual droplets are fragile. Storm systems influence continents. Small and large coexist seamlessly. Nature bridges scales effortlessly. As the night continues, countless clouds remain suspended above the sleeping world. Some drift over oceans, reflecting faint moonlight. Others pass silently above mountain ranges. Others gather above forests where no roads reach. The atmosphere remains active everywhere, even in places untouched by human presence. Especially there, clouds do not require witnesses. Rain does not require attention. The cycle continues regardless. There is comfort in that independence. The world carries on. Rivers flow. Winds move. Clouds form. Rain falls. The great systems of the planet continue their work with quiet persistence. And perhaps that is one of the most soothing lessons hidden within the science of rain. Not every process demands effort. Not every movement requires urgency. Some of the most important changes occur gradually, patiently, one droplet joining another, one cloud forming from countless molecules, one season following another. The atmosphere understands continuity. The rain understands continuity. And beneath the immense darkness of the night sky, those ancient patterns continue unfolding exactly as they have for ages beyond memory. Softly, steadily, without hurry, without end. There are places on Earth where rain seems almost inseparable from the landscape itself. Regions where clouds gather so frequently that moisture becomes part of the identity of the land. Moss spreads across stones. Ferns thrive beneath dense canopies. Streams weave through forests with quiet persistence. The air itself feels softened by water. In such places, rainfall is not merely an occasional event. It is a constant companion, a shaping force working patiently across centuries. The relationship between rain and landscape is one of the oldest partnerships on Earth. Long before humans appeared, rainfall was already sculpting mountains and valleys, already feeding rivers, already influencing the distribution of life. Water is among the most effective architects the planet has ever known, not because it acts quickly, but because it never truly stops. A mountain may seem permanent from a human perspective, solid, unmoving, ancient, and yet rain slowly alters even stone, droplet by droplet, year by year. The process is often imperceptible. A single rainfall changes very little, but over thousands and millions of years, the cumulative effect becomes extraordinary. Valleys deepen, cliffs retreat, Sediments travel toward distant seas. Entire landscapes evolve. Nature often demonstrates the power of persistence. The atmosphere participates in this lesson continuously. Rain rarely arrives with the intention of reshaping the world. Yet, given enough time, it does exactly that. Perhaps some of the most profound transformations occur through repetition rather than force. A quiet truth visible throughout both geology and life. Far above these landscapes, clouds continue their migrations. A cloud may cross forests in the morning, mountains in the afternoon, and oceans by evening. Its existence is brief compared to the land below, yet its influence reaches downward. Moisture connects sky and surface. The atmosphere and the earth engage in an ongoing exchange, a conversation older than memory. One participant moving constantly, the other changing slowly. Together, they create the world we know. When rain falls upon forests, much of it never reaches the ground directly. Leaves intercept droplets. Branches collect moisture. Water pauses among the canopy before continuing its descent. Some evaporates back into the atmosphere. Some drips downward in delayed rhythms. Some travels along trunks. The forest transforms rainfall into a more complex journey. A droplet entering the canopy may follow many possible paths. Nature rarely favors simplicity when complexity offers advantages. The result is a rich interaction between vegetation and water, a collaboration developed over immense spans of evolutionary time. Forests influence rainfall. Rainfall influences forests. The relationship moves in both directions. Scientists sometimes refer to such relationships as feedback systems. Outputs become inputs. Effects become causes. The cycle loops back upon itself. The atmosphere contains many such loops. Indeed, much of Earth's stability depends upon them. Without feedbacks, environmental systems would behave very differently. Instead, countless interactions help regulate conditions across the planet. The atmosphere is not merely a collection of isolated events. It is a network, an intricate web of influences extending across scales. A cloud influences sunlight. Sunlight influences temperature. Temperature influences evaporation. Evaporation influences cloud formation. The cycle continues, each element participating in a larger whole. Elsewhere, above the open ocean, rain falls into waters already containing nearly all the world's liquid surface water. At first glance, the event might seem redundant. Why should rain fall into the sea? The ocean hardly appears in need of additional moisture. Yet the water cycle does not operate according to human notions of necessity. It operates according to physics. Moisture evaporates. Moisture condenses. Moisture returns. The cycle remains impartial. The rain falling into the ocean today may eventually evaporate again, perhaps traveling toward distant continents, perhaps joining a future storm. Nothing is wasted. Everything remains in motion. The atmosphere excels at redistribution, transporting water, transporting energy, connecting environments separated by vast distances. One of the most remarkable aspects of rainfall is that it often begins in invisibility. Water vapor cannot easily be seen. The atmosphere may contain enormous quantities of moisture while appearing clear. Only when conditions change does the hidden become visible. Clouds emerge, fog develops, rain begins. There is something poetic in this transformation. Many important processes remain unseen until a certain threshold is reached. Growth occurs quietly. Understanding develops gradually. Change accumulates beneath the surface. Eventually, the results become visible. Clouds are visible evidence of invisible processes. Rain is visible evidence of invisible journeys. The atmosphere constantly reveals what was already occurring. A person standing beneath a clear sky may assume little is happening overhead. Yet the opposite is true. The atmosphere is always active, always moving, always exchanging energy, always transporting moisture. The apparent calm often conceals extraordinary complexity. The same can be said of the oceans. From above, the sea may appear smooth and uniform. Yet beneath the surface, currents move through darkness. Temperature layers shift. Marine life navigates vast underwater landscapes. Complexity often hides beneath simplicity. Nature repeatedly invites deeper observation. The more carefully one looks, the richer the world becomes. Night rain over the ocean possesses a special kind of solitude. Far from shore, beneath low clouds, rain strikes dark water. No buildings, no roads, no artificial lights, only sea and sky, droplets merging with waves, a cycle completing itself. For most of human history, such scenes remained largely unseen. Today, satellites observe them from orbit. Weather instruments monitor them continuously, and yet their essential character remains unchanged. The rain falls. The ocean receives it. The atmosphere continues moving. Technology expands observation. Nature continues its work. There is something reassuring about that continuity. Scientific understanding grows. Human societies change. The planet's fundamental cycles persist. The water cycle has survived ice ages, mass extinctions, continental rearrangements. Its resilience is extraordinary, not because individual storms endure, but because the system itself continues. Each cloud is temporary. Cycle is ancient. A useful distinction. Many individual things pass away. Patterns endure. A single wave disappears. The ocean remains. A single season ends. The climate continues. A single rainfall concludes. The water cycle persists. The atmosphere teaches continuity through impermanence. The larger pattern survives because its components are always changing. Far above the lower atmosphere lies a region few people ever consider: the stratosphere, a realm extending upward through cold, thin air. Commercial aircraft approach its lower boundaries. Weather largely occurs below it. Yet even here, the atmosphere remains significant. The stratosphere contains ozone, a form of oxygen that absorbs much of the sun's ultraviolet radiation. This protective layer influences life across the planet. Another reminder that Earth's atmosphere is not merely air. It is structure, function, protection. a carefully balanced system shaped over geological time. Rain belongs primarily to the lower atmosphere, but the lower atmosphere exists within a larger context. Every layer contributes something important. The sky is deeper than it appears. When people gaze upward, they often imagine empty space beyond the clouds. In reality, there are many transitions, many boundaries, many regions. The atmosphere gradually gives way to space rather than ending abruptly. The change is slow, layer by layer, density decreasing, air becoming thinner. Eventually, the familiar environment of weather fades into the darkness beyond. And still, beneath all those layers, clouds continue drifting. Rain continues falling. The local and the cosmic coexist. A raindrop striking a leaf and a distant galaxy spinning through space are both parts of the same universe. Different scales, different timescales, different processes, yet connected through the laws of nature. Perhaps one reason atmospheric science feels so calming is that it constantly shifts perspective. One moment, we are considering microscopic droplets. The next, planetary circulation. Then the broader context of Earth itself. The mind expands and contracts across scales. And in doing so, many worries begin to feel less absolute, not unimportant, simply situated within a larger reality. The atmosphere offers perspective without judgment. It reminds us that we inhabit a moving planet, a world of cycles and rhythms, a world where change is natural, where movement is constant, where continuity emerges from transformation. As the hours move quietly onward, rainfall continues somewhere beneath the night sky, perhaps over a mountain range hidden in darkness, perhaps over an empty stretch of sea, perhaps over a forest where only the trees witness its arrival. The droplets fall, the rivers receive them, the oceans await their return. The atmosphere carries on its ancient work, patient as ever, unhurried as ever, a cycle repeating not because it is trapped, but because repetition is one of nature's most elegant forms. Clouds forming, clouds dissolving, moisture rising, moisture falling, the story continuing. The same story, and yet always new. For no cloud is ever exactly repeated, no rainfall perfectly recreated, no moment duplicated. The cycle endures, its expressions change, and somewhere high above, hidden beyond the darkness and beyond the clouds, the stars continue shining silently over it all, watching if stars could watch, illuminating without intention. Present across distances so vast they challenge imagination. While below, on this small blue world, rain continues its gentle descent through the night. A familiar phenomenon, a scientific phenomenon, a beautiful phenomenon, one more chapter in a story billions of years old. Toward the deepest hours of the night, when many homes are quiet and most roads have emptied, the atmosphere often feels different. Not because its physical laws have changed. They remain exactly as they were. Gravity still draws droplets downward. Water vapor still drifts through invisible currents. Clouds still form and dissolve according to temperature, pressure, and moisture. Yet the absence of human activity changes the way we experience these processes. the world becomes easier to hear. A distant rainfall seems closer. A soft wind moving through trees becomes more noticeable. The quiet allows subtle things to emerge, and the atmosphere is full of subtle things. Many of the most important atmospheric processes unfold gradually, without spectacle, without urgency. Consider the cooling of the Earth's surface after sunset. As daylight fades, the ground begins losing heat. Energy radiates outward toward the night sky. Fields cool, forests cool, deserts cool, roads and rooftops cool. The process occurs continuously, a silent exchange between the planet and the darkness above. As surfaces cool, the air nearest to them often cools as well. This can create layers within the atmosphere. Warmer air above, cooler air below. Meteorologists call such situations temperature inversions. The name sounds technical, yet the phenomenon is surprisingly common, and its effects can be significant. Fog may develop, air quality may change, sound may travel differently. The atmosphere acquires structure, not visible structure like mountains or valleys, but thermal structure, layers defined by temperature rather than stone. The sky contains landscapes of its own, invisible topographies shaped by energy and motion. Far above these layers, moisture continues moving through the night. Some of it exists as vapor, some as cloud droplets, some as ice crystals. Water changes, form repeatedly throughout its atmospheric journey. It is remarkably adaptable, able to exist comfortably in several states depending upon local conditions. Few substances influence the planet so profoundly while remaining so flexible. A droplet may become vapor, the vapor may become cloud, the cloud may become snow, the snow may become a river, the river may become ocean, the ocean may become vapor once again. The boundaries between forms are real, yet they are also temporary. Transformation is one of water's defining characteristics. Perhaps that is why it feels so closely connected to time. Water rarely stays where it is forever. It moves, changes, continues. The same is true of clouds. Imagine observing a cloud continuously for several hours. At first, it might appear stable, but gradually its shape would shift. Edges would soften. New structures would emerge. Other structures would disappear. The cloud would evolve, not because anything unusual occurred, but because change is its natural condition. The atmosphere teaches a quiet lesson. Permanence is often an illusion created by limited observation. Given sufficient time, everything reveals movement. Rivers move, glaciers move, continents move, clouds move, even mountains move, though so slowly that generations may pass before the changes become apparent. Time transforms our understanding of stability. Things that seem fixed are often merely changing at scales we do not immediately perceive. Rain belongs to this larger story of movement. The falling droplet is simply the visible part. Its journey began earlier. Its influence continues afterward. Every rainfall exists within a broader timeline, far beyond the moment we experience it. Elsewhere on Earth, lightning flickers inside distant storms. Even when discussing the quiet physics of rain, it is impossible to entirely ignore electricity. Storm clouds often separate electrical charges through collisions among droplets, ice crystals, and particles moving within turbulent air. Over time, these separations can become substantial. The atmosphere accumulates imbalance. Eventually, nature seeks resolution. A lightning discharge occurs. Energy moves. The electrical difference decreases. The event may appear sudden, yet the conditions leading to it developed gradually. Like many phenomena in nature, the dramatic moment is only the conclusion of a longer process. What we notice most easily is often merely the visible ending. The preparation occurred earlier, silently, patiently, hidden from view. Rain itself frequently behaves this way. A shower may seem to arrive unexpectedly, yet the atmosphere has often been preparing for hours, sometimes days, moisture gathering, air masses shifting, clouds developing. The visible event represents accumulated history. A person watching rain through a window witnesses the final chapter of a much longer story. Science excels at uncovering those hidden chapters. The atmosphere becomes richer when viewed through that lens, not less mysterious, more meaningful. Far above the oceans, moonlight occasionally illuminates cloud tops. The scene can appear almost unreal. White formations glowing softly against darkness. Below them, the sea remains largely hidden. Only hints of reflected light reveal its presence. The atmosphere and the ocean engage in constant exchange. Heat moves between them. Moisture moves between them. Energy moves between them. Together, they form one of the most important partnerships on Earth. Neither system can be fully understood in isolation. The atmosphere influences the ocean. The ocean influences the atmosphere. Each shapes the other. Their relationship has persisted for billions of years. Long before forests appeared, long before animals walked on land, long before human beings looked upward and wondered about clouds, the partnership already existed. Ancient oceans evaporated beneath ancient suns. Ancient clouds drifted across ancient skies. Rain fell upon landscapes almost unimaginable today. The cycle is older than nearly every familiar feature of the modern world, and yet it continues around us now. The same fundamental processes operating across immense spans of time. There is comfort in such continuity, not because it guarantees anything, but because it reminds us that some patterns are extraordinarily resilient. The water cycle has survived countless transformations. Ice ages came and went. Continents shifted. Species appeared and disappeared. Still, the atmosphere carried moisture. Still, clouds formed. Still, rain returned water to the surface. Nature often persists through adaptation rather than resistance. The cycle continues because it changes, because it moves, because it remains dynamic. A fixed system would struggle. A flexible one endures. The atmosphere is among the most flexible systems on Earth, always adjusting, always responding, always finding new balances. Even a calm evening reflects countless adjustments occurring simultaneously. Temperatures shift, pressures evolve, winds respond, moisture redistributes. The apparent stillness conceals motion. One of the most beautiful aspects of meteorology is its ability to reveal these hidden movements. The ordinary sky becomes an active environment, a landscape of flows and exchanges, an invisible architecture built from physics. People sometimes imagine science as removing wonder from the world. Yet, atmospheric science often accomplishes the opposite. Understanding why clouds glow at sunset does not diminish their beauty. Understanding how rain forms does not make rainfall less soothing. Knowledge adds layers. It deepens appreciation. The familiar becomes more interesting, not less. A cloud ceases to be merely a cloud. It becomes the visible expression of thermodynamics, fluid motion, solar energy, and water cycling through the planet. A raindrop becomes a traveler, a messenger carrying evidence of processes spanning oceans and skies. The atmosphere transforms ordinary experiences into windows onto larger realities. And perhaps that is one reason people continue studying it. Not simply to predict weather, though prediction is valuable, but because the atmosphere offers a way to understand connections. Connections between local and global, between present and past, between microscopic events and planetary systems. Rain is a perfect example. A tiny droplet reflects enormous processes. The smallest things often reveal the largest truths. Near dawn in some parts of the world, temperatures begin approaching their daily minimum. The long night of cooling nears its conclusion. Fields may glisten with dew. Mist may gather in low places. The atmosphere enters another transitional period, neither fully night nor fully day. A threshold. Nature contains many thresholds, moments when one state becomes another. Water vapor becoming cloud, cloud becoming rain, night becoming morning. These transitions often feel peaceful, not because they lack change, but because change occurs gradually. The atmosphere rarely rushes. Even dramatic weather systems usually develop through stages. Hours of preparation, hours of evolution, hours of decline. The processes unfold in time. Patience is built into their structure. As the earth turns steadily beneath the stars, regions presently wrapped in darkness move slowly toward sunlight. Clouds drift across those regions. Rain falls across those regions. The planet rotates. The cycle continues. From orbit, the movement would appear seamless. Day advancing, night retreating, storms turning, clouds migrating, an entire world in motion. Yet from the surface, the experience remains intimate. A single window, a single rooftop, a single sound of rain arriving in the darkness. Local and the planetary coexist beautifully. One does not replace the other. The vastness of atmospheric science ultimately returns us to simple experiences. The scent of rain, the coolness of damp air, the sound of droplets striking leaves. These moments connect directly to processes spanning continents and oceans. The ordinary touches the immense. And somewhere, beyond the edge of hearing, beyond distant hills and sleeping cities, rain continues falling beneath the night sky. Patient as always, moving through its ancient cycle, returning water to rivers, to forests, to fields, to seas, continuing a journey so old that it predates memory itself. And in the quiet darkness before morning, the atmosphere carries on, unseen, unhurried, endlessly alive with motion. A vast, invisible ocean above the world, breathing moisture across the face of the earth. One cloud, one current, one droplet at a time. As the night slowly approaches its final hours, there is a tendency for the mind to become quieter. Thoughts drift more slowly. Attention loosens its grip on the details of the day. The world outside seems farther away. And perhaps this is an ideal time to consider one of the gentlest truths hidden within the science of rain. Nothing about a raindrop exists in isolation. Every droplet belongs to a history. Every droplet belongs to a future. The moment we witness is only a brief section of a much longer journey. Imagine a single molecule of water, 2 atoms of hydrogen, 1 atom of oxygen, a structure so small that billions upon billions could rest unnoticed within a single droplet. And yet that molecule may have traveled farther than any human explorer. It may once have existed within an ancient ocean beneath skies unlike those we know today. It may have drifted through clouds above extinct forests. It may have passed through glaciers, rivers, wetlands, storms, and seas. The molecule itself does not remember, yet its journey continues. Water is one of nature's great travelers, not because it moves quickly. Often it does not, but because it never truly stops moving forever. The timescales vary enormously. Some water remains in the atmosphere for only days. Some remains in lakes for years. Some becomes trapped within glaciers for thousands of years. Some descends deep underground and remains there for much longer. The cycle contains both motion and waiting, movement and stillness. Nature rarely chooses one without the other. A cloud is movement. A glacier is patience. A river is movement. A deep aquifer is patience. Together they form a complete system. Far beneath deserts, hidden beneath layers of rock and soil, ancient groundwater sometimes rests in darkness. Some of this water entered the ground long before modern cities existed, long before written history, long before many current landscapes acquired their familiar forms. Rainfall from distant ages slowly infiltrated downward. The water remained, protected from sunlight, moving so gradually that human lifetimes become difficult to perceive against its timeline. There's something humbling about such scales. A storm may last a few hours. A river may flow for thousands of years. Groundwater may remain hidden for tens of thousands of years. Different chapters of the same story, different expressions of the same molecule. The atmosphere connects them all. Without rainfall, many underground reservoirs would eventually diminish. Without evaporation, rainfall itself would cease. The cycle depends upon continuity, each part supporting the others. One reason the water cycle feels almost philosophical is that it blurs distinctions between beginnings and endings. When exactly does a raindrop begin? When it leaves the ocean? When it enters a cloud? When condensation first forms? The answer depends upon perspective. Likewise, when does its journey end? When it reaches the ground, when it enters a river, when it returns to the sea? Perhaps there is no definitive endpoint, only transitions. The atmosphere often teaches this lesson. Processes matter more than boundaries. Movement matters more than categories. Water simply continues, changing form as conditions change. The universe contains many cycles. Stars are born and eventually fade. Galaxies evolve, planets orbit, seasons return, water circulates. The scales differ enormously, yet the underlying principle remains familiar. Nature favors transformation, not stasis. Even apparent permanence often conceals gradual change. Consider a lake beneath moonlight. At first glance, it appears still. Its surface reflects the sky. The shoreline remains quiet. The scene seems peaceful and unmoving. Yet beneath that appearance, countless processes continue. Water molecules evaporate. Fish move through deeper layers. Currents shift slowly. Sediments settle. Energy flows. Stillness is often movement viewed from a distance. Rain reveals this beautifully. The atmosphere never truly rests. Even the calmest weather contains activity, invisible exchanges, subtle adjustments, tiny transformations. The sky is always doing something. Perhaps that realization contributes to the feeling of companionship many people experience during rainfall. Rain suggests that the world remains active beyond our awareness. The forests continue growing. The rivers continue flowing. The clouds continue forming. The planet continues turning. We are not responsible for maintaining these processes. They carry on by themselves. There can be comfort in recognizing that. Not every burden belongs to us. The earth knows how to rain. The ocean knows how to evaporate. Gravity knows how to pull. Nature performs countless tasks without instruction. Far above the atmosphere, sunlight continues streaming toward Earth. Even during the night, the sun remains present. The planet has simply rotated away from direct illumination. Elsewhere, daylight shines upon oceans and continents. Evaporation continues there. Clouds develop there. The water cycle never sleeps because the earth never stops turning. Somewhere it is morning. Somewhere it is evening. Somewhere rain is beginning. Somewhere rain is ending. The cycle spans all time zones, all seasons, all landscapes. The atmosphere functions as a global system, an unbroken circulation connecting distant places. Long before satellites allowed humanity to see the planet as a whole, this connectedness existed. People experienced weather locally. They observed storms approaching from nearby horizons. They felt rain falling upon familiar fields and towns. The larger system remained mostly invisible. Today, we can observe cloud formations spanning oceans. We can watch storms crossing continents. We can see atmospheric rivers transporting moisture across enormous distances. Technology has expanded perspective. The atmosphere itself remains unchanged. Its patterns continue as they always have. Only our ability to observe them has grown, and with observation comes appreciation. There is beauty in understanding rainstorm over a mountain range may be linked to moisture that evaporated from a distant ocean. Beauty in recognizing that clouds are not isolated objects, but stages within an ongoing process. Beauty in realizing that familiar experiences often possess hidden depth. Rain may be among the most ordinary events in human life, yet it emerges from one of the most intricate systems on Earth. A remarkable combination, ordinary and extraordinary at the same time. Perhaps many meaningful things share this quality: breathing, sleeping, listening, watching clouds. The most familiar experiences often reveal the greatest complexity when examined carefully. Science and contemplation meet comfortably here. Neither diminishes the other. Understanding enriches reflection. Reflection enriches understanding. The atmosphere provides space for both. As darkness continues to soften the edges of the world, imagine the countless droplets currently suspended within clouds somewhere above the earth. Some drift above oceans, some above forests, some above cities where lights glow quietly through the night. Each droplet waits within a larger process, its future uncertain, its existence temporary, and yet its role meaningful. Together, these droplets form clouds. Together, clouds influence climate. Together, rainfall sustains ecosystems. The individual and the collective coexist, a familiar pattern throughout nature. Stars gather into galaxies, trees gather into forests, droplets gather into clouds. Small things creating larger structures creating new possibilities. The atmosphere demonstrates emergence on a planetary scale, complexity arising naturally from simple interactions. No central planner, no hidden conductor, only physics, only energy, only matter responding to the conditions around it. And somehow, from those ingredients, rain emerges, gentle, persistent, beautiful, near the edges of the polar world, where ice meets sea and long winters shape the rhythm of life. Snowfall often replaces rainfall. Yet even there, the connection remains. Snow is simply another chapter in the story of atmospheric water. Different conditions, different outcomes, the same cycle. Eventually, the snow may melt. The meltwater may join rivers. The rivers may reach oceans. The oceans may contribute vapor to future clouds. Nothing stands apart for long. Nature prefers connection. A mountain stream is connected to the sea. The sea is connected to the atmosphere. The atmosphere is connected to the rain. The rain is connected to the stream once more. The circle closes, then opens again. There is no final repetition because every cycle contains variation. Pattern endures. The details change. Perhaps that is one of the most reassuring characteristics of the natural world. Consistency without rigidity. Order without stagnation. The atmosphere remains reliable precisely because it remains dynamic. It adapts, moves, responds, flows. As the night grows quieter still, and the imagination drifts across oceans, forests, mountains, and clouds, the science of rain begins to feel less like a collection of facts and more like a meditation on continuity. Water rises, water falls, water returns. The process spans generations, Empires come and go. Languages evolve. Cities appear and disappear. Still the clouds gather. Still the rain descends. Still the rivers carry water toward the sea. The cycle persists. Ancient, patient, unhurried. And somewhere, in the darkness beyond the reach of any human eye, a cloud drifts silently through the night, its droplets suspended between earth and space, its future rainfall not yet decided, carried onward by invisible currents, participating in a story that has been unfolding for billions of years, a story still being told, one molecule, one cloud, one quiet raindrop at a time. And now, as the long night begins its slow approach toward morning, there is another aspect of rain worth considering. Not the rain itself, not the cloud, not even the atmosphere, but time. Because the physics of rain is, in many ways, a physics of time. A cloud cannot form instantly. A storm cannot mature instantly. A river cannot carve a valley instantly. The water cycle is a story written through duration, through accumulation, through patience. Nature often appears powerful because of force, but many of its greatest achievements arise through persistence. A mountain may withstand a single storm without difficulty, yet countless storms over millions of years reshape entire landscapes. The atmosphere understands the mathematics of patience. Small effects repeated endlessly become significant. A single droplet seems inconsequential. An entire climate emerges from countless droplets. The same principle appears throughout the universe. Stars shine because countless atomic interactions occur continuously. Galaxies evolve through slow gravitational dances lasting billions of years. Planets change through gradual geological processes. Rain belongs to this family of slow transformations, a quiet participant in the larger story of cosmic time. When viewed from the perspective of a single evening, a rainfall may seem temporary. When viewed from the perspective of geological history, rainfall becomes one of the enduring characteristics of Earth itself. The scale changes, the meaning deepens. Far out across the oceans, waves continue their ancient motion. Some are generated by local winds. Others have traveled extraordinary distances. A swell reaching a shoreline tonight may have originated in a storm thousands of kilometers away. The ocean remembers events through motion. The atmosphere does something similar. Weather carries traces of earlier conditions. A cloud reflects the history of the air that formed it. A storm reflects the history of temperatures and moisture that sustained it. The present contains pieces of the past. Nothing appears from nowhere. Everything has origins. Rain teaches this gently. A droplet falling from a cloud is not the beginning of a story. It is the continuation of one. Long before it became rain, it existed as vapor. Before that, perhaps as ocean. Before that, perhaps as glacier, river, lake, groundwater, or mist. The forms chain. The substance continues. And perhaps this is why water feels strangely eternal. Not because individual droplets survive forever, but because the cycle itself does. The molecules keep moving through different chapters, different roles, different environments. a kind of continuity hidden inside transformation. The night sky offers another perspective on time. Above the atmosphere, stars shine with light that has often traveled for years before reaching Earth. Some starlight arriving tonight began its journey long before many people currently alive were born. Some began even earlier. The universe is full of delayed arrivals, messages traveling through time. Rain contains a quieter version of the same idea. The droplet arriving now may represent moisture that began evaporating days earlier. The river swelling tomorrow reflects rain that fell today. The forest growing next year reflects rainfall from many seasons before. Cause and effect often unfold across long intervals. Nature is rarely in a hurry. One of the reasons rainfall feels calming may be that it invites a slower perception of time. Rain encourages waiting, watching, listening. Its rhythm unfolds at a pace different from much of modern life. There is no urgency in a drizzle, no demand, only continuity, drop after drop, minute after minute. A pattern without haste. The atmosphere often moves this way, not fast from its own perspective, only fast relative to us. Clouds crossing the sky are participating in journeys that may span continents. Weather systems develop over days. Climate patterns emerge over decades. Planetary changes unfold across centuries. The deeper one looks, the more nature seems devoted to gradual transitions. Even dramatic storms usually require long preparation. A thunderstorm may erupt suddenly, yet the moisture had to accumulate. The instability had to develop. The atmosphere had to organize itself. The visible event is only the final act. The preparation happened quietly. This idea appears again and again throughout science. Visible outcomes often depend upon invisible histories. A forest depends upon years of growth. A canyon depends upon ages of erosion. A cloud depends upon countless molecular interactions. Rain becomes a reminder that reality extends beyond immediate appearances. Far beneath the surface of the oceans, darkness remains almost complete. Sunlight never reaches many of these depths. Temperatures remain cold. Pressures become immense. Yet even there, the water cycle maintains indirect influence. Surface processes affect ocean circulation. Ocean circulation affects climate. Climate influences rainfall. Rainfall influences rivers and ecosystems. Connections extend downward into places where no raindrop will ever directly fall. The planet behaves as a system, a network of relationships, an intricate arrangement of feedbacks and exchanges. The atmosphere is only one component, but it is a remarkably important one. Without atmospheric circulation, water would not be distributed as it is. Without clouds, temperatures would differ dramatically. Without rainfall, many landscapes would be transformed beyond recognition. The atmosphere is both delicate and powerful, a thin layer surrounding a planet, yet capable of shaping entire continents through time. There is something beautiful about that paradox. Great influence emerging from apparent fragility. A cloud seems delicate. Yet countless clouds sustain ecosystems. A droplet seems insignificant, yet countless droplets fill rivers. The atmosphere itself seems thin when viewed from space, yet life depends upon it. Nature repeatedly demonstrates that strength is not always obvious. Sometimes resilience appears in subtle forms. A forest survives because it adapts. A river survives because it flows. The water cycle survives because it changes continuously. Flexibility can be a form of endurance. Near the horizon, in places where dawn is beginning to gather, faint changes in light become visible. The darkness softens. Clouds acquire shape. Landscapes slowly reemerge from shadow. Morning approaches not as an event, but as a transition. One state becoming another. The atmosphere is full of such transitions. Vapor becoming cloud, cloud becoming rain, night becoming day. The boundaries often appear clear only after the change has already occurred. While listening to rain, it can sometimes feel as though time itself becomes gentler. Minutes pass differently. The world seems less fragmented, more continuous. Perhaps because rainfall provides a steady reference point, a rhythm against which thought can drift. The sound remains. The droplets continue. The atmosphere carries on. There is comfort in continuity. And continuity is one of the great themes of atmospheric science. The water cycle has no permanent conclusion. Every ending becomes another beginning. Rain becomes river. River becomes ocean. Ocean becomes cloud. Cloud becomes rain once more. A circle so vast that it encompasses nearly the entire planet. A process both simple and profound. One molecule participating in journeys beyond imagination. One cloud carrying moisture across enormous distances. One storm redistributing energy through the atmosphere. Small pieces contributing to larger patterns. Patterns contributing to even larger systems. The universe often builds complexity this way. Layer upon layer. Scale upon scale. Connection upon connection. And still, at the center of all this complexity, remains a familiar experience. Rain falling softly through the darkness. The same sound heard by countless generations before us. The same process studied by scientists, observed by farmers, listened to by travelers, and watched by children standing at windows. Rain belongs to everyone, not because everyone experiences it in the same way, but because it connects us to the same planetary cycle, a shared relationship with water and atmosphere, a shared place beneath the sky. As dawn slowly advances across parts of the earth, clouds continue drifting through pale light. Some release their final droplets. Others continue producing rainfall. Still others dissolve quietly into clear air. The atmosphere never settles into a single form. It remains dynamic, creative, endlessly changing. And perhaps that is the final lesson hidden within the quiet physics of rain. Change is not the opposite of stability. Sometimes change is what creates stability. The water cycle endures because water moves. The atmosphere functions because air circulates. The planet remains habitable because energy flows. Movement sustains continuity. Transformation sustains balance. Rain embodies this truth perfectly. A temporary event participating in an ancient pattern. A brief descent connecting ocean and sky. A gentle reminder that the world is alive with cycles larger than ourselves. And as the last deep hours of night gradually surrender to the approaching morning, the atmosphere continues its endless work. Clouds forming, clouds fading, moisture rising, moisture returning, the story continuing exactly as it has for ages beyond memory. Softly, patiently, under the stars, under the clouds, across oceans and forests and mountains, one quiet drop at a time. In the final stretch of this long night, there is a subtle change in how rain feels when imagined continuously. Earlier, it may have seemed like a subject of science, a system of clouds, vapor, pressure, and temperature. But after so many hours of listening, of following the same cycle through different forms and different scales, it begins to feel less like a system and more like a presence. Something ongoing. Something that does not require attention to continue existing. The atmosphere never asks to be noticed. It simply persists, quietly, across every hour of every day, across every season, across every landscape. Rain is one of its most visible expressions, but even when no rain is falling, the cycle remains intact. Invisible water still moves through the sky. Warm air still rises. Cold air still sinks. Energy still redistributes itself across the planet. The world is never truly still. It only appears still when observed at the wrong scale. At a human scale, a cloud drifting overhead may seem almost motionless. At an atmospheric scale, it is part of a vast circulation system spanning hemispheres. At a molecular scale, it is a constant collision of droplets and vapor. At a geological scale, it is part of a pattern shaping continents over millions of years. The same moment, seen differently. Science often expands perception in this way, not by changing reality, but by revealing the layers already present within it. Rain becomes a doorway into those layers. A single falling drop can be examined from multiple perspectives, as a physical object shaped by surface tension, as a transport of energy and moisture, as a participant in weather systems, as a component of planetary cycles. Each perspective is valid. Each reveals something different, and together they form a more complete understanding of something that once seemed simple. There is a certain humility in this kind of knowledge, because the more deeply we understand rain, the more we realize how much of it occurs beyond direct perception. Most clouds will never be seen by any human eye. Most droplets will fall far from observation. Most atmospheric motion will never be noticed individually. And yet it continues regardless. The earth does not require witnesses. Its systems function independently of attention. Somewhere over the open ocean, a cloud thickens in darkness. Moisture accumulates slowly, invisible at first, then gradually becoming visible as faint whiteness against the night sky. Inside that cloud, countless microscopic interactions unfold. Droplets forming, droplets merging, droplets evaporating, air currents shifting, ice crystals appearing and growing, a system of motion too complex to fully observe from within, and yet entirely ordinary to the atmosphere itself. This is simply how clouds exist, not as static objects, but as processes, temporary arrangements of water and air, always becoming something else. Far below, waves continue moving across the ocean surface. Some are shaped by distant storms, some by local winds, some by gravitational forces linked to the moon. Even the sea participates in cycles of influence. The ocean and atmosphere are inseparable in their relationship, each shaping the other, each responding to the other. Heat moves between them. Moisture moves between them. Energy flows in both directions. The boundary between them is not a separation, but an interface, a place of exchange. Rain is one of the most visible outcomes of this exchange. A moment when the atmosphere returns water to the surface, not as vapor, not as cloud, but as liquid. Tangible, falling, noticeable. Yet even this moment is temporary. The water does not remain. It continues into soil, into rivers, into plants, into oceans once again. The cycle is not linear. It is circular, or perhaps more accurately, it is continuous, without a true beginning, without a final end, just ongoing transformation. In many ways, rain is a kind of memory, not memory in the human sense, but a record of prior conditions. Every drop reflects the temperature, humidity, and movement of air that shaped it. Every storm encodes the history of energy flows that formed it. The atmosphere is constantly writing and rewriting these records, and then erasing them through motion. A paradoxical archive, one that exists only while it changes. Elsewhere, in regions where mountains meet moist air, clouds often gather along slopes like slow-moving tides. As air rises, it cools. As it cools, it condenses. As it condenses, it becomes visible. A mountain becomes a generator of weather simply by existing. Its shape influences airflow. Its height influences temperature. Its presence influences rainfall patterns. Even solid land participates in atmospheric behavior. The Earth is not divided into separate systems. It is a continuous interaction of systems. Land influencing air, air influencing water, water influencing land, each shaping the others over time. And through all of it, rain acts as a translator between states, turning vapor into liquid, turning sky into stream, turning atmosphere into river. There is a kind of elegance in that role, not dramatic, not forceful, but essential, as if the atmosphere speaks in one form and the earth receives it in another. In the quietest hours before morning, when light has not yet returned, but night is no longer at its deepest, the world can feel suspended. A transitional moment, neither fully dark nor fully bright. This in-between state is familiar to the atmosphere. It exists in transitions constantly. Clouds are transitions. Rain is a transition. Even weather systems are transitions between states of energy. Nothing remains fixed. Everything moves through phases. And perhaps this is the most consistent characteristic of the natural world, not permanence, but change that follows patterns, reliable change, predictable transformation, a kind of order expressed through movement. The water cycle is one of the clearest expressions of this principle. It is not a straight line. It is not a single event. It is a continuous loop of energy and matter moving through different forms. Ocean becomes vapor. Vapor becomes cloud. Cloud becomes rain. Rain becomes river. River returns to ocean, and the cycle begins again. Each loop slightly different, each cycle influenced by countless variables, yet the structure remains recognizable, like a rhythm played endlessly with infinite variation. There is something deeply calming in this structure, not because it is simple, but because it is consistent without being static. The atmosphere does not repeat itself exactly, but it does not abandon its patterns either. It balances continuity and change in equal measure. As dawn approaches more closely now, the faintest suggestion of light begins to spread across the horizon. Clouds that were once invisible gain subtle definition. Edges appear. Shadows soften. The world begins to reassemble itself from darkness. And still, even as the light returns, the atmosphere continues its work. Moisture still moves. Air still circulates. Clouds still evolve. Rain still falls in distant places. The cycle does not pause for sunrise. It does not pause for night. It does not pause at all. It simply continues. And perhaps that is the final quiet comfort hidden within the physics of rain, that beneath all visible change, there is continuity, not stillness, but persistence, a system so vast and so patient that it does not require recognition to endure. So as the night finally yields to morning, and the long hours of darkness begin to soften into light, the rain continues somewhere beyond sight, and the atmosphere, as always, remains in motion, gentle, unending, present in every direction. One more drop, one more cloud, one more quiet moment in a cycle that never truly stops. By the time morning fully arrives, rain rarely feels like an event that has begun or ended. It feels instead like something that was always there, continuing in parallel with everything else. The ground is wet, but not because the rain finished. It is wet because the atmosphere and the surface exchanged water for a time, and then moved on to a different arrangement. This is how the earth behaves most of the time. Not in clear beginnings, not in clean endings, but in transitions that overlap. Rain is simply one of the more visible transitions. As daylight strengthens, clouds reveal more detail. What was once a uniform gray becomes layered. Thin streaks of vapor drift above thicker masses of condensed water. Some regions of the sky brighten faster than others, depending on humidity, altitude, and the angle of sunlight filtering through the atmosphere. Even now, the clouds are not static. They are still moving, still evolving, still part of the global circulation that has no real pause. Meteorologists describe this motion in terms of pressure systems. High pressure regions where air slowly sinks. Low pressure regions where air rises and expands. Between them, winds flow, carrying moisture, across the surface of the planet. It is an invisible choreography, a constant redistribution of energy and water. No single place is ever truly separate from the others. A storm over an ocean can influence humidity over land. A dry region can influence cloud formation thousands of kilometers away. The atmosphere behaves less like a collection of weather and more like a single interconnected organism of motion. Not alive in the biological sense, but undeniably active and deeply unified. When sunlight returns more fully, evaporation begins again in earnest. Puddles left from the night's rain start to thin at their edges, not disappearing immediately, but gently returning upward into vapor. The same process that formed clouds is already beginning again on the ground. A quiet reversal, a continuation of the cycle. In this way, rain is never truly separate from evaporation. They are two expressions of the same system, one upward, one downward, one invisible, one visible. Between them lies the atmosphere, continuously mediating the exchange. Far above, in the upper layers of the sky, the temperature changes again with altitude. Warm air near the surface supports moisture in one form. Higher up, colder regions encourage condensation into ice crystals or droplets. This vertical structure is part of why clouds can appear so different from one another. Some are flat and stretched across the sky like soft sheets. Others rise in towering formations that seem almost architectural. Some are thin enough to let sunlight pass almost unchanged. Others are dense enough to dim the day into a muted, diffuse glow. Each form is a reflection of local atmospheric conditions: temperature, humidity, wind shear, pressure gradients. The sky is constantly being shaped by invisible forces, and yet to the human eye, it often appears calm. This contrast is one of the most remarkable aspects of weather, the appearance of stillness overlying continuous motion. Even a clear sky is not empty. It contains water vapor. It contains moving air. It contains energy shifting across scales too small to notice directly. The atmosphere is always active, even when it seems quiet. Rain simply makes that activity visible. In a single falling drop, countless processes converge: condensation, collision, growth, gravity, air resistance, surface tension. Each droplet is a small summary of atmospheric physics, a brief physical record of conditions above the ground. And when thousands or millions of these droplets fall together, the result becomes what we recognize as rainfall, something simple enough to describe in a sentence, yet complex enough to occupy entire fields of study. There is a strange comfort in that duality, that something so ordinary can also be so vast in explanation. It suggests that ordinary experience is not shallow, only layered. Consider how sound changes during rain. At first, individual droplets can be distinguished, a soft tapping on leaves or metal. Then, as intensity increases, those individual sounds merge. They become a continuous texture, a steady presence rather than separate events. This is how human perception often works with natural systems. Detail dissolves into pattern, and pattern becomes the primary experience. The atmosphere itself behaves in a similar way. Individual molecular collisions are countless and discrete, but at scale, they form smooth fields of pressure, temperature, and flow. Continuity emerges from discontinuity. Order emerges from repetition. Rain is one of the most accessible examples of this principle, because we can both hear it as individual impacts and experience it as a unified sound. Both views are true. Neither is complete alone. As the morning continues, distant parts of the world are still in darkness. In those regions, night rain is still falling. Clouds are still forming. Storms are still developing over oceans and continents. The earth is large enough that no single moment describes it entirely. While one place dries, another wets. While one region warms, another cools. While one storm fades, another begins. The atmosphere is not localized. It is global, and its processes are continuous across the entire surface of the planet. This is why meteorology often requires looking at large-scale patterns. Jet streams flowing high in the atmosphere. Ocean currents influencing humidity. Seasonal shifts altering entire circulation systems. The weather of one place is always partially connected to the weather of another. Separation is an illusion created by distance. In reality, everything is part of one moving system, and within that system, rain plays a central role in redistribution. Water is constantly being moved, from ocean to air, from air to land, from land back to ocean. This movement is not linear in space or time. It loops, it overlaps, it repeats with variation. A single molecule of water may take a path that is impossible to predict in detail, but the overall pattern remains stable. That stability is what makes life possible. If rain were completely irregular, ecosystems would struggle to adapt. If evaporation stopped, clouds would cease. If clouds stopped, rainfall would end. Instead, the system maintains balance through feedback. Too much moisture leads to rainfall. Too little leads to increased evaporation. The system adjusts continuously, not toward perfection, but toward persistence. And persistence is enough. As light strengthens further, the sky begins to open more clearly. Cloud edges sharpen. Shadows become more defined. The atmosphere, however, remains unchanged in its fundamental behavior. It is still moving, still exchanging energy, still carrying moisture across unseen paths. Even in full daylight, much of this activity remains invisible. We see the results, not the full process. We see rain. We do not see all the vapor that preceded it. We see clouds. We do not see all the turbulence that formed them. We see weather. We do not see the full system that produces it. And yet, with time and attention, more of it becomes understandable. Not less mysterious, but more connected, more coherent, more deeply interwoven. Perhaps this is the quiet gift of studying something like rain. It takes something that feels simple and reveals its hidden depth, not to complicate it, but to expand it, until a single raindrop is no longer just a droplet, but a moment in a vast, continuous cycle that includes oceans, skies, continents, seasons, and time itself. And even as this long night finally ends and morning fully arrives across the world, the atmosphere continues exactly as it always has, uninterrupted, unhurrying, unfolding, one cycle blending into the next, one cloud dissolving into another, one drop becoming part of something larger, and the rain, somewhere beyond sight, continues its quiet work, as it always has, as it always will. By now, the morning has fully settled in across many parts of the world, yet the atmosphere carries no memory of having changed shifts. It does not recognize night or morning as boundaries, only as conditions. Light increases, temperature adjusts, winds respond, and moisture continues its movement through every available layer of air. The system remains continuous, unbroken, even when human perception divides it into moments. This is one of the quiet truths behind atmospheric science. The weather does not restart each day. It never resets. It simply evolves. A cloud that forms at dawn is not new in the sense of beginning from nothing. It is the outcome of processes that have already been unfolding through the night. Moisture accumulated, air rose and cooled, energy redistributed across the surface of the planet. The visible structure is only the latest expression of a longer sequence, and as the sun climbs higher, evaporation becomes more active again. Rivers release water into the air. Forests contribute moisture through transpiration. Soils slowly return absorbed water back into vapor form. Even after rain has ended, the cycle continues feeding itself. Nothing in the system truly pauses. It only changes direction, upward, downward, sideways through winds that span continents. The atmosphere behaves like a vast circulation engine powered by uneven heating from the sun. Where sunlight is stronger, air rises. Where it is weaker, air sinks. These differences create movement. Movement creates clouds. Clouds create rain. Rain redistributes water across the surface. And the surface, in turn, influences future atmospheric motion. This feedback loop is one of the defining structures of Earth's climate system, a continuous negotiation between energy and matter, between ocean and sky, between land and air. Far above the surface, in regions where commercial aircraft occasionally pass, the air begins to thin noticeably. Winds there are often faster and more organized, flowing along narrow channels known as jet streams. These high-altitude currents play a subtle but important role in guiding weather systems. They can steer storms. They can separate warm and cold air masses. They can influence where rain will fall days in advance. Even something as local as a morning drizzle may be connected to these large-scale flows. The atmosphere is layered not only vertically, but dynamically. Different heights carry different kinds of motion, different temperatures, different behaviors, and yet all layers remain connected. A disturbance in one region can eventually propagate into another, like ripples moving through a fluid that spans the entire planet. Rain often feels personal because it happens at ground level, but its origins are rarely local alone. Moisture may have traveled across oceans before becoming part of a cloud above a city street. Air masses may have interacted with distant mountain ranges. Temperature patterns may have shifted over days across entire hemispheres. The rain arriving in one moment is the end point of a much longer journey. And yet, when it falls, it feels immediate, present, here. This contrast between global origin and local experience is one of the most fascinating aspects of meteorology. The Earth is both intimate and vast at the same time. A single drop of rain connects both scales. At ground level, water interacts with soil in quiet ways. It seeps into tiny spaces between particles. It is absorbed by roots. It fills small channels that gradually converge into streams. From there, it joins larger rivers. Eventually, it returns to the ocean. But even this return is not an ending. The ocean is not a final destination. It is a reservoir, a temporary resting phase in a continuous cycle. Sunlight will eventually draw that water back into the atmosphere again. The same molecule may participate in countless cycles over time. It may become cloud, then rain, then river, then ocean, then cloud again. There is no fixed identity for a water molecule within this system. Only participation. Only movement through states. Perhaps this is why water often feels symbolic of change itself. It is never permanently one thing. It is always becoming something else. Even ice, which appears solid and stable, is simply another temporary arrangement of the same molecules. Under different conditions, it will transform again, return to liquid, then to vapor, then back into cloud. The atmosphere is a stage where these transformations occur continuously. A vast laboratory of phase changes driven by temperature and pressure. Yet, nothing about it feels artificial. It is entirely natural, entirely unplanned, and yet profoundly structured. Clouds remain one of the most visible expressions of this structure. Their shapes are not random, even when they appear soft and undefined. They reflect the underlying physics of air movement and condensation. Some clouds form in calm conditions, spreading gently across the sky. Others form in turbulent regions, rising rapidly in towering columns. Some clouds signal stable weather. Others signal approaching storms. For centuries, people learned to read these patterns intuitively. Before formal science, observation was the primary tool. A darkening sky, a sudden shift in wind, a particular shape forming at the horizon. These were early forms of atmospheric understanding. Even today, despite satellites and computer models, observation remains essential. There is something direct about looking at the sky, something immediate. No instrument replaces the simple act of noticing. Perhaps that is part of why rain feels so universally recognizable. It requires no explanation to be understood at a sensory level. The sound alone is enough. The sight alone is enough. The feeling of cool moisture in the air is enough. Science adds depth, but not necessity. Rain is complete even without interpretation, and yet interpretation reveals how deeply interconnected it is with everything else. As the morning continues, evaporation resumes across wet surfaces left behind by earlier rainfall. Puddles shrink gradually. Soil releases moisture. Plants draw water upward and return part of it to the air. The cycle begins again, in smaller, quieter forms. Not dramatic like storms, but continuous, subtle, persistent. The atmosphere never stops exchanging water with the surface. Even in dry regions, moisture exists in small quantities, constantly shifting between states. Even in cold regions, sublimation allows ice to transition directly into vapor under certain conditions. The system is flexible enough to operate across extremes. That flexibility is one of the reasons it endures. Earth's atmosphere has persisted through enormous changes in geological history. Shifts in continents, variations in solar intensity, changes in atmospheric composition, and still water has remained central. Still clouds have formed. Still precipitation has occurred in some form or another. Rain is part of a system that has adapted across unimaginable timescales, and yet it remains familiar enough to be heard outside a window on an ordinary morning. This duality is part of its quiet power. It is both ancient and immediate, both global and local, both simple and complex. As the light becomes fully established, the sky opens further. Clouds thin in some regions while thickening in others. The atmosphere redistributes its moisture again, preparing for future conditions that may or may not lead to new rainfall. The system does not aim toward a specific outcome. It responds to energy flows as they occur. It adapts continuously. In that sense, the atmosphere is not a machine moving toward a goal. It is a process maintaining itself through constant adjustment, a balance that is never perfectly fixed, only continuously approached. And through all of this, rain remains one of its most accessible expressions, a moment when invisible processes become visible, when vapor becomes substance, when sky becomes sound, when the distant becomes immediate. And as this long sequence of reflection continues toward its final stretch, it becomes clear that rain is not only a subject of science, it is also a reminder that even the most ordinary experiences are embedded in systems far larger than they appear. That simplicity often rests on complexity, and that beneath the changing sky, the atmosphere continues its quiet, endless work, unseen, unbroken, always moving, always becoming, one cycle flowing into the next. As the day continues to unfold, the atmosphere settles into its familiar rhythm of exchange, as if nothing remarkable has occurred at all. Rain, when it happens, often feels like an interruption to daily life. Yet, from the perspective of the planet, it is not an interruption. It is continuity. The atmosphere does not distinguish between weather and non-weather. It only exists in states of motion and transformation. Clear skies are simply another expression of the same system that produces storms. Dry air is not the absence of weather. It is a different configuration of moisture, temperature, and pressure. even silence in the sky is still part of the same ongoing process. The water cycle continues beneath every condition, not only during rainfall, but also in its absence. Evaporation proceeds quietly wherever liquid water exists. Condensation occurs wherever conditions allow. Vapor is constantly shifting between visible and invisible forms. This constant transition is what defines the atmosphere more than any single event. A storm may be dramatic. A rainfall may feel complete, but neither is separate from the quieter background processes that persist before and after. In this way, weather resembles music more than machinery, not a sequence of isolated actions, but a continuous composition of changing patterns, some moments louder, some softer, some nearly imperceptible, yet all part of a single unfolding structure. Far above the surface, sunlight continues to warm different regions of the earth unevenly. The equator receives more direct energy than the poles. Land heats faster than water. Dry surfaces respond differently than moist ones. These differences create gradients, and gradients create motion. Air begins to flow from areas of high pressure to low pressure. Moisture is carried along with it. Clouds form where rising air cools. Rain appears where condensation becomes heavy enough to fall. The entire system is driven not by intention, but by imbalance. A constant attempt to redistribute energy more evenly across the planet. Yet perfect balance is never reached, because as soon as equilibrium is approached, the conditions that created it begin to change again. The earth is never still long enough to settle. It is always rotating, always receiving sunlight, always releasing heat back into space. This constant flux ensures that weather never fully repeats itself. Patterns may resemble one another, but exact duplication does not occur. Every storm is unique in its specific arrangement of conditions. Every rainfall carries subtle differences in intensity, timing, and structure. Even the sound of rain varies depending on surface, temperature, and droplet size. Rain on leaves is not the same as rain on stone. Rain on water is not the same as rain on metal. Each interaction produces a distinct acoustic signature, yet all are recognized as the same phenomenon. This is one of the remarkable aspects of perception. The brain recognizes pattern across variation. It understands rain not as a single sound, but as a family of related sounds. Science mirrors this process in its own way. It identifies underlying principles beneath variation, equations that describe droplet formation, models that simulate atmospheric circulation, concepts that unify seemingly different weather events. Still, even the most advanced models do not capture every detail. The atmosphere contains too many interacting variables, too many small-scale processes occurring simultaneously. Turbulence alone introduces layers of complexity that are difficult to fully predict. This is not a flaw in understanding. It is a reflection of the system itself. The atmosphere is inherently complex, not chaotic in the sense of randomness, but sensitive, responsive, interconnected, Small changes can influence large outcomes over time. A slight difference in temperature here, a minor shift in pressure there. These can alter the path of a storm days later. This sensitivity is part of what makes weather both fascinating and challenging to study. Yet despite this complexity, large-scale patterns remain stable. Seasons return, monsoons arrive, trade winds persist, climate zones maintain structure over long periods. There is order within variability, predictability within change. The atmosphere balances both simultaneously, and rain exists at the intersection of these two qualities. It is structured enough to be studied, variable enough to remain unpredictable in detail. As the day progresses further, the memory of night rain begins to fade from immediate attention. But its effects remain visible. Soil still holds moisture. Air still carries humidity. Plants still reflect the water they absorbed. The landscape is temporarily altered, even if the event itself has passed. Rain always leaves traces, even when it is no longer falling. In this sense, rain extends beyond its duration. Its influence persists, a reminder that time is not divided into isolated moments, but into overlapping effects. What happens in 1 hour can shape the next day. What happens in one day can influence the next season. What happens in one storm can affect an entire ecosystem. Everything is connected through sequences of cause and response. Far beyond Earth, in the cold expanse of space, other worlds experience their own versions of atmospheric cycles. Some planets may have clouds composed not of water, but of other substances. Some may experience rains of exotic materials under extreme conditions. Yet, Earth remains unique in its familiarity. Water rain is rare in its ability to support life as we know it. Liquid water exists within a narrow range of temperature and pressure. Within that range, complexity becomes possible. Chemistry becomes dynamic. Biology becomes viable. Rain, therefore, is not just a weather phenomenon. It is part of what makes Earth a living world, a continuous redistribution of one of life's most essential substances, from ocean to sky, from sky to land, from land back to ocean, a loop that sustains countless forms of existence, and all of it driven by sunlight and gravity acting through the atmosphere. There is no central control, no guiding intelligence directing each drop, only interactions, only physics unfolding consistently over time. Yet from those simple principles arises an environment rich enough to support forests, oceans, cities, and consciousness itself. This is one of the most quietly astonishing aspects of the natural world. Complexity emerging from simplicity, order emerging from motion, meaning emerging from pattern. As the afternoon light continues to grow, clouds begin to shift again in distant regions. Some will eventually produce new rainfall. Others will dissipate without releasing a drop. The atmosphere makes no distinction between outcomes. It simply evolves according to conditions, and conditions are always changing. Temperature fluctuates, pressure shifts, moisture redistributes, energy flows, the system remains alive with movement, even in moments of apparent calm, even in clear skies, even in silence. Rain is only one expression of this constant activity, a visible moment within an invisible continuum, a brief clarity in an ongoing process. And as this long exploration continues toward its final phase, the same truth remains gently present beneath every observation. The atmosphere is never finished. It never completes itself. It never stops. It only continues, one transformation at a time, one cycle at a time, one quiet, drifting drop at a time. As the day moves deeper into its steady middle hours, the atmosphere appears at its most ordinary, not storming, not collapsing into dramatic formations, not announcing itself with thunder or sudden change. Instead, it settles into what is often called fair weather, though even that phrase suggests a kind of misunderstanding. There is no fairness or unfairness in the sky, only conditions, only states of energy and moisture that happen to be arranged in a stable configuration for a while. In these quieter moments, it becomes easier to forget that the atmosphere is still fully active. Clouds may be sparse or distant, but that does not mean the system has paused. It simply means that water is distributed differently at this moment in time. Some of it is in rivers, some in soil, some in plants, some in invisible vapor, some in distant clouds that have not yet reached the stage of releasing rain. The cycle remains intact in every location at once, even in places where nothing appears to be happening. This is one of the more subtle truths about Earth's climate system. Activity is not always visible. Motion is not always dramatic. Change does not require spectacle. Often, the most important processes are quiet, gradual, distributed across space and time. Evaporation, for example, rarely draws attention. A puddle shrinking beneath sunlight does not announce itself. A wet road slowly drying carries no sound. Yet in those moments, vast numbers of water molecules are leaving the surface and entering the atmosphere. Invisible ascent replacing visible presence. The reverse of rainfall happening constantly across the planet. Forests contribute even more subtly. Through transpiration, trees release water vapor through microscopic openings in their leaves, not as waste, but as part of their internal regulation of temperature and nutrients. This biological contribution to atmospheric moisture is so extensive that entire weather patterns can be influenced by large forested regions. What appears as still green landscape is, in reality, participating in atmospheric exchange at every moment. Even soil contributes. Even rocks, over long timescales, release and absorb moisture depending on conditions. The boundary between land and air is not fixed. It is porous, always exchanging, always adjusting. Above all of this, winds continue their slow planetary circulation, driven by uneven heating from the sun, shaped by the rotation of the Earth, redirected by continents and oceans. These winds are not random. They follow large-scale patterns that repeat across seasons and latitudes. trade winds near the equator, westerlies in mid-latitudes, polar easterlies near the extremes. These patterns form the backbone of atmospheric motion. They guide clouds, they transport moisture, they influence where rain is likely to occur. Yet even these patterns are not rigid. They shift slightly over time, responding to temperature changes in oceans, responding to seasonal solar angles, responding to slow variations in Earth's energy balance. The atmosphere is stable, but never fixed, predictable, but never identical. This balance is what allows weather forecasting to exist at all. Without structure, prediction would be impossible. Without variability, prediction would be unnecessary. The atmosphere sits between these extremes, structured enough to understand, complex enough to remain uncertain, and rain exists directly within that space of uncertainty. A cloud may look heavy with moisture, but whether it will release rain depends on small details of temperature, pressure, and droplet interactions. Sometimes the conditions align. Sometimes they do not. From below, it can appear as though the sky is deciding, but there is no decision, only thresholds being crossed or not crossed. Physics operating without intention. As sunlight continues its steady movement across the sky, shadows shorten and then begin to lengthen again, depending on location. The Earth's rotation ensures that every region eventually experiences both illumination and darkness. This cycle of day and night is the most fundamental rhythm of atmospheric behavior because it drives temperature change. And temperature change drives everything else. Without day and night, there would be no familiar weather patterns, no daily heating and cooling, no regular cycles of evaporation and condensation. The atmosphere would still exist, but it would behave in a very different way. It is this rotation that gives the water cycle its rhythm, not in steps, but in continuous variation. As surfaces warm, evaporation increases. As surfaces cool, condensation becomes more likely. Clouds form in response. Rain follows where conditions allow. And then the cycle resets locally, even as it continues globally. At any given moment, somewhere on Earth, rain is falling. At the same time, somewhere else, water is evaporating. Elsewhere, clouds are forming. Elsewhere, clouds are dissolving. The system is always active somewhere, even when it appears calm in a specific place. This global simultaneity is one of the most important aspects of atmospheric science. It prevents the system from ever truly stopping. The water cycle is not a sequence. It is a network of simultaneous processes distributed across the entire planet. Each region participates differently depending on local conditions. Yet all regions remain connected through the same underlying physics. As the afternoon light grows slightly warmer, evaporation from oceans increases again. The ocean is the largest reservoir of water on Earth. Its surface is constantly exchanging moisture with the air above it. Waves increase surface area. Wind enhances evaporation. Sunlight provides energy. From this interaction, vapor rises into the atmosphere, eventually forming clouds, eventually becoming rain, and then returning once more to the sea. It is a cycle without preference for origin or destination. Water moves because energy allows it to move, not because it is directed toward a goal. And yet the outcome supports the stability of the planet's climate. It is a system that maintains itself through continuous redistribution, not equilibrium, but dynamic balance, a balance that is always being approached, but never fully reached. Far above, thin clouds may pass unnoticed across the sky. They may not produce rain at all, yet they still represent movement within the system. Even a cloud that never rains is still part of the atmospheric circulation of water. It may evaporate later. It may merge with other clouds. It may travel hundreds of kilometers before dissolving. Nothing in the atmosphere is wasted. Everything is reused. Everything is recycled. Everything returns in some form. This is one of the most defining characteristics of Earth's surface system. Closed loops, continuous recycling, interconnected cycles of matter and energy. And at the center of one of these cycles is rain, a moment when vapor becomes visible, when sky becomes substance, when invisible motion becomes audible sound. It is both ordinary and essential, both brief and connected to vast timescales. As the day continues, human activity resumes across many regions. Cities hum with movement. Vehicles travel along roads. Energy systems distribute power. Yet, above all of this, the atmosphere continues its independent behavior, unconcerned with observation, unchanged by attention. Clouds form regardless of whether anyone looks up. Rain falls regardless of whether it is noticed. Winds move regardless of interpretation. The atmosphere does not pause for awareness. It continues its cycles with or without witnesses. And perhaps there is something quietly grounding in that realization, that the world is active beyond perception, that systems persist beyond attention, that the rain you hear or do not hear is part of a much larger continuity. As this long exploration approaches its final moments, the same image remains consistent. A planet wrapped in a thin, dynamic layer of air, water moving endlessly between forms, energy flowing through every scale, and rain always somewhere as one of its most delicate expressions, falling, rising, returning, continuing without beginning, without end. Only change that never stops. In the final stretch of this long, continuous day, there is a subtle shift in how everything feels, not in the atmosphere itself. It remains unchanged in its laws, unchanged in its motions, unchanged in its quiet exchanges of water and energy. But in attention, in awareness, in the way the mind begins to loosen its focus and allow the world to simply be what it already is, the sky does not become simpler. It only becomes less demanding to interpret. Clouds drift without needing explanation. Light spreads across them without asking to be understood. And rain, whether present or remembered, settles into the background of thought like a familiar rhythm that no longer needs to be followed closely. The atmosphere has always been like this, a system that does not require observation to continue, a process that does not depend on recognition, a cycle that does not pause for understanding. It simply exists and continues. In earlier hours, it may have felt important to trace each part of the water cycle carefully, to follow vapor rising from oceans, to follow clouds forming in cooling air, to follow droplets descending through gravity and returning to rivers, soil, and sea. But now, in this quieter phase, it becomes possible to see the entire cycle at once, not as steps, but as a single continuous movement, a turning, a circulation, a breathing system spread across the surface of an entire planet. There is no true separation between beginning and ending within it, only phases that appear different depending on where attention is placed. Ocean is not separate from cloud. Cloud is not separate from rain. Rain is not separate from river. River is not separate from ocean. They are all expressions of the same material moving through different conditions. Water does not leave the system. It only changes its form of participation. And the atmosphere is the medium through which these transformations become possible. A thin, fragile-looking layer when seen from space, yet responsible for nearly all visible weather on Earth. It is easy to forget how delicate this layer is, how narrow compared to the scale of the planet beneath it, and yet how essential. Without it, oceans would remain still and locked. Without it, sunlight would strike the surface without redistribution. Without it, there would be no clouds forming in distant skies, no soft accumulation of moisture, no gradual release of rain into forests or fields. The presence of the atmosphere is what allows water to move between states, between places, between moments in time. In that sense, rain is not simply a phenomenon occurring within the atmosphere. It is one of the ways the atmosphere expresses its function, a visible outcome of invisible structure, a moment when the hidden becomes audible, when the unseen becomes felt. As this long narrative approaches its final stillness, it is worth noticing how familiar rain has become over these hours of thought, not through repetition of detail, but through deepening context. At first, it was clouds and droplets, then circulation and systems, then planetary connections spanning oceans, continents, and seasons. And now, it is simply continuity, a single process seen from many distances at once. The closer one looks, the more detailed it becomes. The farther one steps back, the more unified it appears. Both perspectives are true simultaneously. The atmosphere exists in both clarity and complexity at the same time, and rain is where those two views meet. A small event that carries large meaning, a simple sound that represents vast motion, a moment of contact between sky and surface that echoes through entire systems of climate and life. As the world continues its rotation, some places are entering night once again. Others are reaching midday. Others are in the soft transition between the two. And everywhere, regardless of time, the atmosphere remains active. Moisture still moves through invisible paths. Air still rises and falls in slow circulation. Clouds still form where conditions allow. And somewhere, in some quiet region beyond immediate awareness, rain is falling again. Not as an interruption, not as an event separate from the rest of the world, but as part of its ongoing structure, the same structure that has always been present, the same structure that will continue long after any single moment has passed. There's a kind of calm in recognizing this, not because everything is still, but because nothing is isolated. Everything belongs to something larger. Every drop belongs to a cloud. Every cloud belongs to a circulation. Every circulation belongs to a planet. And the planet itself is part of a larger cosmic arrangement of motion and time. Even silence, even stillness, is part of that arrangement, because it is only a perception of scale, not a cessation of process. And so, as this long journey through the quiet physics of rain comes to rest, there is nothing that truly ends. No final transformation, no closing moment in the atmosphere, only continuation, only the soft persistence of systems that do not require attention to exist, only water moving where it can move, only air responding where it must respond, only clouds forming where conditions allow, only rain returning what was always part of the earth. And beyond all description, beyond all observation, beyond all thought about it, the world continues exactly as it has for billions of years, uninterrupted, unfinished, unfolding, like a slow breath that never quite ends, like a quiet rainfall that never fully disappears, like a sky that never stops becoming itself. And as the final moments of this long narration settle into silence, nothing is concluded.